Hello students, welcome to Momentum Masters. At Momentum Masters, we believe in one simple idea. Right direction creates the right momentum. Boards are not about studying more, it is about studying the right thing. And when your basics are clear, confidence comes directly. So in this series, we are going to study science directly from NCERT, a quick revision before board exam. Today, we are starting with chapter number 1, Chemical Reactions and Equations. Just remember one thing, chemistry is not about reactions. It's about transformation. Transformation of old substances into new substances with new properties. So let's begin with the chapter. The first page of the chapter gives you few examples from day-to-day life like grapes get fermented, cooking of food, digestion, respiration. These all are examples of chemical changes. These chemical changes occur due to chemical reactions. Whenever there is a chemical reaction, there is a formation of new substances. So the first activity in the book is given about the reaction Mg plus O2 give rise to MgO. That is when magnesium ribbon react with air, it gives magnesium oxide. In this activity, you have to remember few points. First point is rubbing of ribbon by the help of sandpaper. Why we do so? We do so to remove the oxide layer. Second point is production of magnesium oxide, which is white powder. The color of magnesium oxide. Third important step is white dazzling flame. During production of during the reaction, a white dazzling flame is produced. This is the sign of MgO production. Let's move to next page. On second page, we have two more examples of chemical reaction. Activity number 1, where lead nitrate is treated with potassium iodide. In this reaction, PPT, precipitate, is formed. It is PbNO3 twice give plus potassium iodide give rise to lead iodide plus potassium nitrate. This lead iodide is yellow PPT. Now the definition of PPT is a insoluble substance produced when two aqueous solution react. Right. Okay, the next activity, activity 3, where zinc granules react with acid. Zinc is a metal. This reaction help you in both the chapters, chapter number 1 and in chapter number 3 also, metals and non-metals. Here, zinc, a metal, reacting with HCl, hydrochloric acid, it gives rise to zinc chloride ZnCl2 plus hydrogen gas. Always represent hydrogen gas with H2 and an arrow upside, which means gas is releasing. We can do the same reaction with sulfuric acid also. So on reacting with sulfuric acid, it again forms the same salt and hydrogen, not same salt, sulfate salt. Above we have a salt from chloride family, and in the second reaction we will have a salt from sulfate family. The next point is signs of a chemical reaction. So, what are the physical signs which shows that a chemical reaction occurs? It is change in state, change in color, evolution of gas and change in temperature. Okay, if the question is what are the signs of chemical reaction, then mention all the 4 points with one example each. For change in state, you can take the example of water hydrolysis, that is when H2 and O2, hydrogen gas and oxygen gas, react with each other, it forms H2O, which is in liquid state. So this is an example of change in state where two gases react and a liquid is formed. Another example of color. So color example is when iron react with copper sulfate, it give rise to iron sulfide plus copper. Here this copper sulfate is blue in color, and after reaction the solution changes its color to pale green. So this is an example for change in color. Next example, evolution of gas. For evolution of gas, you can use the equation chemical reaction which we studied in activity number 1.3, that is zinc reacting with hydrochloric acid give rise to zinc chloride and hydrogen gas. So this is evolution of gas. Remember one more point, this hydrogen gas is released with popping sound. It does not release with popping sound. Basically, when you bring a matchstick near the container, the matchstick burns with a popping sound. This shows the presence of hydrogen gas near the container. Next is change in temperature. Change in temperature, you can give the same example, because when zinc react with hydrochloric acid, it is an exothermic reaction where conical flask become hot. Here they even in activity 1.3 they have even asked, touch the conical flask or test tube, is there any change in temperature? Yes, it becomes hot. Okay, so in change in temperature you can use the same reaction as an example, or you can write one more example. Let's take an example of any exothermic reaction when calcium chloride calcium carbonate react with water, it gives rise to CaOH twice. Okay, let's move further. Another one is chemical equation. Next chapter, next heading is our chemical equation. Chemical equation is representation of chemical reaction. Now this chemical equation can be represented as word equation. When magnesium combined with oxygen, it gives rise to magnesium oxide, where reactants are written on the left hand side and products are written on the right hand side. Next page. Changing chemical a word equation into a skeletal form. skeletal form is nothing, it is representing word equation in the chemical formula. We have changed the same reaction as Mg plus O2 give rise to MgO, chemical formulas of the same compounds and elements. The next step towards it is balanced chemical equation. What is the principle behind balanced chemical equation? It is law of conservation of mass. And how we balance a chemical equation? By number of atoms of each element, by balancing number of atoms of each element on the both sides. As we are looking at above example, is Mg plus O2 is balanced reaction? No, it is not balanced. Mg plus O2 give rise to magnesium oxide, as it is not balanced because on left hand side we have one atom of magnesium, on right hand side we have one atom of magnesium, whereas for oxygen it is two on left hand side and one on right hand side. So for balancing it, we multiply right hand side with 2. So when we multiply MgO with 2, Mg has 2 atoms and it changed the count of oxygen on right hand side. Now it is also 2. So balance this, we again make some corrections on the left hand side and change it to 2. So 2 Mg plus O2 give rise to 2 MgO. This is the balanced chemical equation. There is one more example for the same. When zinc react with sulfuric acid, it gives rise to zinc sulfate plus hydrogen. This is word equation. The skeletal form is Zn plus H2SO4 give rise to ZnSO4 plus H2. When we look the number of atoms on both sides, here you can see zinc is balanced on both sides, and so do hydrogen, sulfur and oxygen. So you can't say कि a skeletal equation is always unbalanced. Sometimes it is balanced also. There is one more example given in the book for balancing, that is Fp plus H2O give rise to Fp3O4 plus H2. That is when iron reacts with water, it gives rise to ferric oxide and hydrogen gas. As you can see, here iron is not balanced and others are not balanced. Let's learn its balancing in the next page. So step 1, identify number of atoms on both the sides for each element. So Fe plus H2O give rise to Fe2O3 plus H2. Okay, now let's make table. Left hand side, our elements are iron, hydrogen and oxygen. On left hand side there is one iron, 2 hydrogens and 1 oxygen. On right hand side we have, sorry, formula is wrong, Fe3O4. So on right hand side we have 3 iron atoms, 4 oxygen atoms and 2 hydrogen atoms. So here only hydrogen is balanced, iron and oxygen atoms are not balanced. So for balancing them, let's first change for iron, multiply left hand side with 3 to balance it. So we add a coefficient 3 in front of iron. Second step, with this change there is no other change taking place. So we can directly move to step number 2. Now let's balance oxygen. So balancing oxygen on left hand side, we multiply again with 4. When we add a coefficient 4 in front of water, it changes the count of hydrogen on left hand side. Now the hydrogen count on left hand side becomes 8. Now again chemical reaction unbalanced. To balance hydrogen On right hand side we multiply it with 4. So by multiplying it with 4, we add a coefficient in front of hydrogen gas as 4. So now again calculating 3 iron on left hand side, 3 iron on right hand side. 4 to the 8 hydrogens on left hand side, 4 to the 8 hydrogens on right hand side, and 4 oxygens on left hand side and 4 oxygens on right hand side. So this is a balanced chemical equation, but it is not the appropriate representation of a chemical reaction. It is partly balanced equation. So the last step towards completing a reaction into a balanced form is substituting the symbols of their physical states. So the reaction which we have written on previous pages, 3Fe when reacts with 4 molecules of water give rise to Fe2O3 plus hydrogen gas. So it is gas, so we represent G in bracket. This is rust, we represent S in bracket. Water is G. You will be asking me ki why water is G, not L, because iron reaction with water, with cold water, is a slow process. Hence, in this part, so hence in this reaction, we are reacting it with steam. So this is steam, hence that's why we have written G here. Iron again a metal, so S. So representing their physical states. Also, there are few other things like sometimes some reactions require some specific conditions of temperature, pressure or a catalyst. So these all conditions must be mentioned overhead on the arrow between reactants and products. So in this reaction, as you see, when carbon monoxide reacting with hydrogen gas at 340 atmospheric pressure, it gives rise to methanol. Remember this compound because it is also part of our syllabus. Methanol, first member of alcohol family, methanol, which is in liquid state. There is one more reaction given here. This is photosynthesis reaction. Where 6 carbon dioxide molecules reacting with 12 water molecules in the presence of sunlight and chlorophyll give rise to glucose and oxygen and water. This reaction is the reason why we call plants as autotrophs. So this is the reaction of glucose formation. There is one more thing in this reaction. As you see, there are 6 molecules of water on right hand side and there are 12 molecules of water on left hand side. When you balance this reaction by the hit and trial method, which we have learned above, you will balance this as 6 CO2 plus 7 H2O in the presence of sunlight. Don't draw the triangle. There is difference between triangle and sunlight. Sunlight is the light given by sun. Triangle represent the heat. In triangle we heat the products. Chlorophyll that is present into the leaves, chloroplast में, give rise to C6H12O6 plus 6 oxygen molecules plus water molecule. अगर आप ये वाली रिएक्शन भी लिख के आते हैं तो भी आपकी रिएक्शन बैलेंस्ड ही रहेगी. एज यू कैन सी देयर आर 6 कार्बन एटम्स on left hand side, 6 carbon atoms on right hand side. Okay, 6 carbon on right hand side and 6 carbon on left hand side. ठीक है, and you will have 6 into 2 and 7 into 1, total 12 plus 7, 19 oxygens on left hand side, and 6 to the 12, 6 into 2 is 12, plus 1 oxygen here and plus 6 oxygen from glucose. So total 12 plus 7, again 19. So it is balanced. It's not mandatory. You will write 6H2 on this side. अगर आप मैथमेटिक्स से भी सीखेंगे तो अगर आप राइट हैंड साइड वाले 6H2Os को लेफ्ट हैंड साइड लेके आते हैं और 12 में से 6 माइनस करेंगे तो स्टिल 6H2O इज लेफ्ट. ठीक है, तो ये इट्स अ बैलेंस रिएक्शन इन फॉर्म ऑफ 7H2O ऑल्सो. आप 7 वाला फॉर्म भी लिख सकते हैं और आप ये वाला भी याद कर सकते हैं दोनों. कुछ बच्चों के लिए नया पॉइंट होगा शायद, जिन्होंने शायद ना ध्यान दिया हो कि ये H2O कहाँ से आया. प्लांट्स नेवर रिलीज वाटर, ऐसा नहीं है. प्लांट्स डू रिलीज वाटर इन द फॉर्म ऑफ ट्रांसपीरेशन, लॉस ऑफ वाटर फ्रॉम द प्लांट्स. For this adaptation, the cactus change its leaf into the forms of thorn. And also you will have one more activity in bio section where transpiration, the activity which shows that plant is showing transpiration, where you use a poly bag over the leaf and after some time you saw some water droplets into the poly bag, and this shows that plant release water during photosynthesis. Let's move to next page. Okay, so here are a few questions, in-text question. In-text questions are important, so let's discuss them first. First is, why should a magnesium ribbon be cleaned before burning in air? We already have studied in slide number 1 that to remove oxide layer. Next, write the balanced equation for the chemical reaction. Hydrogen plus chlorine give rise to hydrogen chloride. Hydrogen plus chlorine give rise to hydrogen chloride. First of all, write it into skeletal form. Now, there are 2 hydrogen on left hand side and 1 hydrogen on right hand side. Again chlorine, 2 chlorines on left hand side and 1 chlorine on right hand side. So simply by multiplying it with 2 we can balance. So this is the balanced. Again next is barium chloride. Barium chloride, BaCl2, aluminium sulfate, Al, SO4, SO4 की वैलेंसी 2, so Al2 SO4 thrice, aluminium की वैलेंसी 3 होती है. Next it give rise to barium sulfate, Ba की वैलेंसी 2 होती है, सल्फेट की भी 2, so it forms BaSO4 plus aluminium chloride, aluminium की वैलेंसी 3, chloride की वैलेंसी 1, so Al3, AlCl3, AlCl3. Now balance it. You have 2 atoms of aluminium on left hand side and 1 atom on right hand side. So balance first aluminium. Let's add 2 here. When we now calculate the chloride, we have 2 chlorines here and 2 3 ja 6 chlorine this side. So add 3 in front of barium chloride. Now you will have 3 barium, and so balancing that again add 3 in sulfate, barium sulfate. So 3 barium, 3 sulfurs, 3 sulfurs, 3 fours are 12 oxygen, 3 fours are 12 oxygen. So it is the balanced reaction. So 3 BaCl2 plus 2 plus Al2SO4 thrice give rise to 3 BaSO4 plus 2 AlCl3. Question number 3. Write a balanced chemical equation with state symbols for the following reactions. Solution of barium chloride and sodium chloride in water react to give insoluble barium sulfate and the solution of sodium chloride. Okay, it is sodium, so this is barium chloride, Ba, barium chloride, BaCl2 reacting with sodium sulfate, Na2SO4 in water, मतलब ये aqueous solution हो गए. So mention AQ in along this. This is also in aqueous state to give insoluble barium chloride sulfate, BaSO4. It's white PPT, mention S behind it, plus solution of sodium chloride NaCl in aqueous state. ठीक है. बैरियम क्लोराइड और सोडियम क्लोराइड वैसे तो सॉल्ट्स होते हैं, बट यहाँ वो वाटर के एक्वस स्टेट में लिए गए हैं तो फॉर द रिएक्शन टू अकर. सो दिस इज थर्ड क्वेश्चन का फर्स्ट पार्ट. सेकेंड इज सोडियम हाइड्रोक्साइड सॉल्यूशन reacts with hydrochloric acid. Sodium hydroxide NaOH, again water में है तो aqueous solution, reacting with hydrochloric acid HCl. HCl को भी हम aqueous solution ही कहेंगे क्योंकि जब आप उसको पानी में डालेंगे तो ions dissociate हो जाएंगे H positive ion Cl में. It give rise to sodium chloride NaCl. solution word लिखा है तो आप aqueous मेंशन करेंगे एंड वाटर H2O. अच्छा, ये रिएक्शन न्यूट्रलाइजेशन रिएक्शन भी है. where acid is reacting with base and you know the salt form is neutral because both acid and base are strong here. So when a strong acid react with a strong base, it give rise to a neutral salt and we call it a neutralization reaction. Okay, then let's move to next topic, chemical reactions, types of chemical reaction. The first type of chemical reaction is combination reaction. Combination, when you have more number of reactants and only one product. So identification is one product. And the representation is when A plus B give rise to C. ये होती है आपकी combination reaction. So the first combination reaction example here is when slaked lime, formation of slaked lime, when calcium oxide react with water. Calcium oxide reacting with water, calcium oxide common name quicklime. ठीक है, देखो CaO and CaOH whole twice. CaOH whole twice बोलने में टाइम लगता है जबकि CaO क्विकली बोला जाता है. तो आप याद रख सकते हैं जो क्विकली बोला जाए दैट इज क्विकलाइम. सो CaO इज क्विकलाइम reacting with water give rise to slaked lime, that is calcium hydroxide. कैल्शियम की वैलेंसी 2 होती है, हाइड्रोक्साइड आयन की वैलेंसी 1 होती है, हेंस कंपाउंड इज CaOH होल ट्वाइस. यहाँ पे वर्ड लिखा है हीट इन प्रोडक्ट, इसका मतलब ये कैसी रिएक्शन हो गई हमारी, thermic. It is exothermic reaction. Exothermic chemical reactions are those reactions where heat is evolved, heat release reactions होती हैं. Let's move to few more examples of this combination reaction. One is burning of coal. When carbon react with oxygen, give rise to carbon dioxide. एक और एग्जाम्पल फॉर्मेशन ऑफ वाटर, अभी हमने ये स्टेट चेंज में भी पढ़ा था. इट इज ऑल्सो स्टेट चेंज रिएक्शन. Here hydrogen gas react with oxygen gas, give rise to two molecules of water in liquid state. Always read these do you know columns. Here slaked lime produced here reacts with carbon dioxide and give rise to calcium carbonate and water. जो कैल्शियम कार्बोनेट होता है, दिस कैल्शियम कार्बोनेट फॉर्मेशन टेक 2 to 3 days. That's why when we have whitewashing, what is the use of calcium hydroxide? We use it into whitewashing. So when calcium hydroxide react with the carbon dioxide present in the in nature or the room, it starts shining. So if they ask what makes wall shine after 2-3 days, it is the formation of calcium carbonate. So remember this reaction when slaked lime used in whitewashing. Formed by the quick lime. The slaked lime react with carbon dioxide present in the environment, give rise to CaCO3, calcium carbonate, and this calcium carbonate is responsible for shining of the walls. Okay, this gives you shiny finish, and this reaction take place into 2 to 3 days. Okay, as you knew, we also studies that this calcium, slaked lime, calcium hydroxide formed in previous page is a exothermic reaction. So NCERT gives you few more example for exothermic reaction. Natural gas, burning of natural gas is also a exothermic reaction. All the fossil fuels, be it coal, petroleum, these all are exothermic. ये burning exothermic ही होती हैं. Most of the burning is exothermic. Oxygen is involved in the burning, and there is always some production of heat as a byproduct. Natural gas का मेन कॉन्स्टिट्यूएंट CH4 होता है. CH4 का नाम होता है मीथेन, द फर्स्ट मेंबर ऑफ alkane family. Remember these points. Okay, digestion, your digestion is also exothermic reaction. कहा जाता है ना कि स्टमक में हीट प्रोड्यूस हो जाती है, बॉडी वार्म अप हो जाती है खाना खाने के बाद, वो भी एक एक्सोथर्मिक रिएक्शन है, इसीलिए ऐसा होता है. यहाँ पे कार्बोहाइड्रेट्स ब्रोकन डाउन हो जाते हैं टू फॉर्म ग्लूकोज. हम कॉम्प्लेक्स कार्बोहाइड्रेट्स खाते हैं, अब उनकी ब्रेकिंग की रिएक्शन भी ग्लूकोज reacting with oxygen give rise to carbon dioxide, water and a lot of heat. This heat is make it a exothermic reaction. Vegetative compost formation, composting is also a exothermic reaction. So आपको इस पेज पे एक्सोथर्मिक रिएक्शंस के काफी एग्जांपल्स दिए गए हैं. कोल बर्निंग, मीथेन बर्निंग, then natural gas burning, glucose digestion, composting, these all are exothermic reactions. Next, the second type is decomposition reaction. Decomposition reaction, activity 1.5. Activity 1.5 में फेरस सल्फेट क्रिस्टल्स आपने लिए हुए हैं एंड फेरस सल्फेट क्रिस्टल्स का जो कलर होता है वो आपका ग्रीन होता है। इन्होंने कहा नोट करें कि उनका कलर क्या होगा, उनका कलर ग्रीन होता है। आप लोगों ने स्टेट चेंज में एक रिएक्शन मैंने पढ़ी थी, Fe प्लस CuSO4 वाली, वही से पेल ग्रीन कलर के ये होते हैं। आपने इनको बर्न किया तो क्रिस्टल्स का कलर चेंज हो जाता है हीटिंग के टाइम पे, ठीक है। तो उसी को यहाँ पे रिप्रेजेंट किया। चलिए, ग्रीन कलर ऑफ फेरस सल्फेट, तो आपको पहला पॉइंट मिल गया, ग्रीन कलर के फेरस सल्फेट्स हैं। इनको जब आप हीट कर रहे हैं, इट गिव्स टू फेरिक ऑक्साइड, सल्फर डाइऑक्साइड एंड ट्राइऑक्साइड। आपको दो गैसेस वो दे रहे हैं। अब आप देख रहे होंगे कि डिकम्पोजिशन रिएक्शन में डिकम्पोज हो रहा है, ब्रेक डाउन हो रहा है। सो डिकम्पोजिशन इज ब्रेक डाउन, breakdown. So identification is one reactant. Decomposition reactions में we have only one reactant which split into many products. Many products, more than one product होंगे वहां पर, 2 3 कितने भी हो सकते हैं, ठीक है। ओके, अब इस रिएक्शन में कुछ पॉइंट्स बहुत ही इंपॉर्टेंट हैं जो हमें याद रखने हैं। जैसे कि यहाँ पर आपका रिएक्टेंट ब्रेक हो रहा है और फेरस सल्फेट क्रिस्टल्स। अब सबसे पहले FeSO4 7H2O, यहाँ पे जो ये डॉट 7H2O लिखा है, इनको कहते हैं वाटर ऑफ क्रिस्टलाइजेशन। These are water of crystallization. ये हर मॉलिक्यूल्स के साथ अलग अलग होते हैं। CuSO4 के साथ 5H2O मॉलिक्यूल्स ऑफ वाटर, 5H2O क्रिस्टलाइजेशन मॉलिक्यूल्स होते हैं। CaSO4 के साथ 2H2O होते हैं इन जिप्सम स्टेट। और अगर आप POP में पूछेंगे तो 1.5 हो जाता है, CSO4 डॉट हाफ H2O, ये आपकी POP स्टेट होती है। इसी तरह वॉशिंग सोडा Na2CO3, उसमें 10 H2O मॉलिक्यूल्स होते हैं। ये पूछे जाते हैं वाटर ऑफ क्रिस्टलाइजेशन इन डिफरेंट। 10 को डेका कहते हैं, डेका हाइड्रेट। इसी तरह 5 को पेंटाहाइड्रेट कहेंगे, 7 को हेप्टा हाइड्रेट कहेंगे। सो इट FeSO4.7H2O का केमिकल नेम क्या बना? फेरस सल्फेट हेप्टा हाइड्रेट। ओके, नाउ दिस जब आप इसको हीट करते हैं, इट लूज दिस वाटर ऑफ क्रिस्टलाइजेशन, जिसकी वजह से क्रिस्टल्स का कलर चेंज हो जाता है। चेंज होके क्या बन जाता है? कलरलेस। वो ग्रीन कलर से कैसा हो गया है? कलरलेस हो गया है, ठीक है। तो ये आपसे केस स्टडी में भी पूछा जा सकता है कि एक सब्सटेंस था विच इज ग्रीन कलर, विच इज हैविंग ग्रीन कलर क्रिस्टल्स, यू हीट इट एंड आफ्टर हीटिंग कलर लॉस्ट, नदर न्यू कलर इज, ऐसे पूछ सकते हैं। नेक्स्ट, अब ये डिकम्पोज होके क्या बना? फेरिक ऑक्साइड, और दो इसने गैसेस रिलीज करी, दैट इज सल्फर डाइऑक्साइड एंड सल्फर ट्राइऑक्साइड। वो दोनों गैसेस हैं। फेरिक ऑक्साइड इज सॉलिड इन स्टेट। अब अगर आप यहाँ देखेंगे तो इस डायग्राम फिगर 1.4 इज इंपॉर्टेंट। यहाँ पे आप दो तीन चीजें देख सकते हैं। पहला, वेफ्टिंग गैस जेंटली टूवर्ड्स द नोज, डू नॉट पॉइंट द माउथ of boiling tube toward at your neighbors or yourself. Why we should not do this? Because ये दोनों ही गैसेस पंजेंट स्मेल की होती हैं, स्मेली गैसेस होती हैं, इनमें से स्मेल आती है, एंड पॉइजनस ऑल्सो। दे रिएक्ट विद द वाटर प्रेजेंट इन द नेचर एंड ये एसिडिक टर्न हो जाती हैं, तो पॉइजनस होती हैं और स्मेली होती हैं, इसलिए वी शुड नॉट पॉइंट इट टूवर्ड्स अदर। There is one more example, again जो कैल्शियम कार्बोनेट हमने बनाया था शाइनिंग वॉल के लिए जो रिस्पॉन्सिबल था, उसका कॉमन नेम लाइम स्टोन होता है। इस लाइम स्टोन को भी जब हम हीट करते हैं, इट गिव राइज टू क्विक लाइम एंड कार्बन डाइऑक्साइड गैस। दिस इज थर्मल डीकम्पोजिशन, क्योंकि हमने यहाँ पर डिकम्पोज ब्रेक डाउन करने के लिए किसका यूज किया है, हीट का यूज किया है। So this is first type of decomposition reaction, that is thermal decomposition. अब thermal decomposition पे एक्टिविटी 1.6 में एक और रिएक्शन के बारे में बात किया गया है, और वो रिएक्शन है जब आप लेड नाइट्रेट, Pb is lead, NO3 is nitrate, होल ट्वाइस लिखा जाता है बिकॉज लेड की वैलेंसी 2 होती है। जब आप लेड नाइट्रेट को बॉयल करते हैं, हीट, हमारे पास एक ही रिएक्टेंट है इसलिए इट्स डिकम्पोजिशन। जब आप इसको हीट कर रहे हो तो इसमें भी नाइट्रोजन डाइऑक्साइड और डाइऑक्साइड गैसेस रिलीज होती हैं, और एक पॉइंट यहाँ पे मेंशन है ब्राउन फ्यूम्स। जो ये नाइट्रोजन डाइऑक्साइड गैसेस होती है, इसकी कैरेक्टराइजेशन या आइडेंटिफिकेशन आप ब्राउन फ्यूम्स से कर सकते हो। जब कोई चीज बर्न होती है तो उसके अराउंड एक फ्यूम्स डेवलप होते हैं, उसका कुछ कलर होता है, एंड दैट कलर हियर इज ब्राउन। ओके, नेक्स्ट पेज पे आपको वो रिएक्शन दी गई है, PbNO3 twice heated give you lead oxide NO2 नाइट्रोजन डाइऑक्साइड गैस, जो कि ब्राउन फ्यूम्स प्रोड्यूस करती है, एंड ऑक्सीजन गैस। सो दिस इज सेकेंड एग्जाम्पल ऑफ थर्मल डिकम्पोजिशन। एक्टिविटी 1.7 आपको सेकेंड टाइप ऑफ डिकम्पोजिशन समझाती है, एंड दैट सेकेंड टाइप इज इलेक्ट्रोलिटिक डिकम्पोजिशन। इलेक्ट्रोलिटिक डिकम्पोजिशन में हम इलेक्ट्रिसिटी का यूज करते हैं टू ब्रेक द सब्सटेंस। दिस इज वन ऑफ द मोस्ट इंपॉर्टेंट एक्टिविटी फ्रॉम दिस चैप्टर। केस स्टडी में भी आ जाती है, समटाइम्स 3 मार्क का क्वेश्चन भी इससे पूछा जाता है। तो आपको डायग्राम भी लर्न करना है। इसमें आपने कंटेनर यूज किया है जिसमें आपने 2 इन्वर्टेड इलेक्ट्रोड्स को लगाया है विद द 6 वोल्ट बैटरी। जो एंड आपका पॉजिटिव से कनेक्टेड है उसको एनोड कहेंगे, जो नेगेटिव से कनेक्टेड है उसे हमने कैथोड कहा है। दीज आर ग्रेफाइट रोड्स। नाउ आपने वाटर यूज किया एज अ मीडियम, और वाटर के अंदर आपने HCl, डाइल्यूटेड HCl को यूज किया है, डाइल्यूटेड सल्फ्यूरिक एसिड। सल्फ्यूरिक भी डाल सकते हैं, HCl भी डाल सकते हैं, NaCl भी डाल सकते हैं, सॉल्ट भी यूज कर सकते हैं। बेसिकली इस एसिड या सॉल्ट का पर्पस सिर्फ रिएक्शन को फास्टर करना है, रिएक्शन रेट इंक्रीज करना है, रेट ऑफ रिएक्शन आपका इंक्रीज हो जाता है। अदरवाइज डिकम्पोजिशन बहुत स्लो होता है। आप जैसे ही किसी एसिड या सॉल्ट को वाटर के अंदर डालते हैं, वो डिसोसिएट हो जाता है आयंस में, और ये आयंस फ्लो ऑफ इलेक्ट्रिसिटी को हेल्प करते हैं, और वाटर का डिसोसिएशन फास्टर हो जाता है। अब यहाँ पर आपको 2-3 पॉइंट्स याद रखने हैं, जैसे कि फर्स्ट ऑफ ऑल रिएक्शन। नाउ H2O is decomposing to form हाइड्रोजन गैस एंड ऑक्सीजन गैस। ऑक्सीजन आयंस नेगेटिव होते हैं, इसलिए एनोड पे आपकी ऑक्सीजन फॉर्म होती है। आपको रोड्स याद रखनी है, किस रोड पे कौन सी गैस प्रोड्यूस होगी, और इस एनोड पे ऑक्सीजन है तो कैथोड पे आपकी हाइड्रोजन गैस प्रोड्यूस हो रही होगी। याद रखने का तरीका वेरी सिंपल, ऑक्सीजन आयंस नेगेटिव, एनोड पॉजिटिव, नेगेटिव पॉजिटिव अट्रैक्ट ईच अदर। देन अगर आप इसको बैलेंस्ड फॉर्म में लिखते हैं, हाइड्रोजन ट्वाइस ट्वाइस बट ऑक्सीजन बैलेंस नहीं है। जब मैं ऑक्सीजन को बैलेंस कर रही हूँ तो मुझे हाइड्रोजन गैस के 2 मॉलिक्यूल्स रिसीव हो रहे हैं। So when they ask the ratio, so you read 2:1, H2 रेशो ऑक्सीजन। ज्यादा गैस कौन सी रिलीज होगी? हाइड्रोजन इज रिलीज्ड मोर एट कैथोड। कैथोड पे हाइड्रोजन गैस ज्यादा रिलीज होती हुई आपको दिखाई देगी, ये उसका रीजन है। एक्टिविटी 1.8 जिसके अंदर सिल्वर क्लोराइड अगेन सिल्वर कलर का होता है, ये सिल्वर क्लोराइड इज AgCl। जब आप AgCl को सनलाइट में रखते हैं तो आपकी क्लोरीन गैस इवेपोरेट हो जाती है एंड सिर्फ सिल्वर पीछे स्टे बैक करता है। सिल्वर क्लोराइड टर्न्स ग्रे, ये सिल्वर कलर से किस कलर में चेंज करता है? ग्रे कलर में। तो ये भी पॉइंट आपको याद करना है कि ग्रे कलर में चेंज होता है। एंड दिस टाइप ऑफ डिकम्पोजिशन इज नॉन एज photolytic decomposition. And third and last type of decomposition. Okay, use of this reaction is also asked. You will write next page we have, and there is also the same reaction with bromine also। सिल्वर का कॉम्बिनेशन ब्रोमीन के साथ, सिल्वर का कॉम्बिनेशन क्लोराइड के साथ, which is changing gray color to silver। This color change is important, remember this, MCQs में इस पे क्वेश्चन आता है। And the use of this reaction is used in black and white photographies। तो आपने पढ़ा डिकम्पोजिशन रिएक्शंस में जिस फॉर्म में एनर्जी यूज करी जाती है उसी फॉर्म के बेसिस पे उसका नाम हो जाता है। अगर आप हीट से करते हैं तो थर्मल, आप लाइट से करते हैं तो इलेक्ट्रोलिटिक, एंड अगर आप सनलाइट से करते हैं तो इट इज फोटोलिटिक। इम्पॉर्टेंट बात ये है कि जितनी भी आपकी डिकम्पोजिशन रिएक्शंस होती हैं उनको हम एंडोथर्मिक रिएक्शंस कह सकते हैं। एंडोथर्मिक रिएक्शंस वो रिएक्शन होती हैं जो कि एब्जॉर्ब करती हैं हीट को। अभी आप देख रहे होंगे कि इन सभी रिएक्शंस में आपने एनर्जी दी है। ओके, अब इन्होंने बैरियम हाइड्रोक्साइड की एक एक्टिविटी लिखी हुई है। सो नेक्स्ट पॉइंट इज कैरी आउट द फॉलोइंग एक्टिविटी। इस पे एक्टिविटी नंबर नहीं है बट ये रिएक्शन पार्ट ऑफ द सिलेबस हो जाएगी। बैरियम हाइड्रोक्साइड BaOH होल ट्वाइस, बैरियम की वैलेंसी 2 होती है, हाइड्रोक्साइड की 1। एड 1 ग्राम ऑफ एमोनियम क्लोराइड, इट्स एमोनियम बच्चा, नॉट एल्यूमिनियम। एमोनियम होता है NH4, सो NH4Cl। ओके, इट इज अ बेसिक सॉल्ट बिकॉज ये HCl एक स्ट्रॉन्ग एसिड से बना है और एक वीक बेस के साथ। एंड मिक्स विद द हेल्प ऑफ अ ग्लास रोड, touch the bottom of the test tube with your palm. What do you feel? It is an exothermic or endothermic reaction? It is an endothermic reaction, give rise to BaCl2 plus NH4OH। okay, NH4OH। होल वंस लिखने की जरूरत नहीं होती, NH4OH इज इनफ। ठीक है, होल में 2 लिखते हैं, 1 को मेंशन करने की जरूरत नहीं होती है। लेट्स, इट इज नॉट बैलेंस्ड, आप इसको बैलेंस कर सकते हैं। देयर आर 2 क्लोरीन्स ऑन द राइट हैंड साइड, तो उसको बैलेंस करने के लिए हमने लेफ्ट हैंड साइड में एमोनियम क्लोराइड के साथ 2 ऐड किया। नाउ वी हैव 2 मॉलिक्यूल, 2 कंपाउंड आयंस ऑफ एमोनियम, so उसे बैलेंस करने के लिए we'll add 2 into the product, so now it is balanced। okay, question number 1 from the in-text question। A solution of substance X is used in white washing. व्हाइट वॉशिंग के लिए यूज होता है जिसका नाम बड़ा होता है CaOH होल ट्वाइस, कॉमन नेम स्लेक्ड लाइम, एंड केमिकल नेम होता है कैल्शियम हाइड्रोक्साइड। ओके, नेम बता दिया, फॉर्मूला हमने लिख दिया। राइट द रिएक्शन ऑफ सब्सटेंस एक्स नेम्ड इन वन अबव विद वाटर। अब आपका ये सब्सटेंस, ओके, देयर इज अ स्मॉल चेंज हियर, यहाँ पर X substance will be CaO and reaction is CaO reacting with H2O give rise to CaOH whole twice. Exothermic reaction, quick line से click the line. Question number 2. Why is the amount of gas collected in one of the test tubes in Aqueous 1.7 double the amount collected in the other? Name the gas. यहाँ पे 2 molecules of hydrogen मिलते हैं, 1 molecule of oxygen मिलता है, रीजन इज बैलेंसिंग। या फिर आप लॉ ऑफ कंजर्वेशन ऑफ मास भी मेंशन कर सकते हैं। लेट्स मूव टू नेक्स्ट type of reaction, that is displacement reaction. So displacement reaction is when a more reactive element displaces a less reactive element. More reactive element displaces less reactive element. ओके, यहाँ पे एग्जाम्पल में आपको 2 आयरन नेल्स दी गई है कॉपर सल्फेट के सॉल्यूशन में। कॉपर सल्फेट सॉल्यूशन का कलर एज यू कैन सी ब्लू है, और जब आप उसमें आयरन की नेल्स डाली तो ये ब्लू टू ग्रीन हो जाएगा, पेल ग्रीन कलर का हो जाता है। लेट्स मूव टू नेक्स्ट पेज। here it is written, see it is blue earlier and pale green color after reaction. तो रिएक्शन क्या है हमारी? when iron which is more reactive than copper displaces copper from the sulfate ion and form iron sulfate and copper as element. कुछ और एग्जाम्पल यहाँ दिए हुए हैं जिंक एंड लेड का, विद द सेम कॉपर सल्फेट के साथ ZnSO4 जिंक सल्फेट बना है, एंड लेड ने कॉपर को डिस्प्लेस करके लेड क्लोराइड बनाया है एंड कॉपर निकल गया है। इन रिएक्शंस के लिए द मोस्ट इंपॉर्टेंट थिंग इज आपका जो फर्स्ट एलिमेंट है वो मोर रिएक्टिव होना चाहिए कंपाउंड एलिमेंट से। कंपाउंड में जो एलिमेंट है उससे मोर रिएक्टिव होना चाहिए। तो अगर रिएक्शन आता है, क्या कॉपर रिएक्ट करेगा H2SO4 के साथ? ये बहुत कॉमनली पूछा जाता है। यू विल से नो रिएक्शन बिकॉज कॉपर इज लेस रिएक्टिव देन हाइड्रोजन, तो वो हाइड्रोजन को डिस्प्लेस नहीं कर पाएगा। द नेक्स्ट टाइप इज डबल डिस्प्लेसमेंट रिएक्शन। तो हाँ, आपको इससे पहले वाले पेज पे अगर हम जाएंगे तो डिस्प्लेसमेंट की आपको जनरलाइज्ड फॉर्म लिख देती हूँ मैं, व्हेन A रिएक्ट्स विद BC। एक बात याद रखिएगा, डिस्प्लेसमेंट रिएक्शन में एलिमेंट इज यूज्ड अगेंस्ट अ कंपाउंड, then AC a product is formed and B is released as element. Whereas in double displacement reaction you are going to use two compounds. Here two compounds are used, AB plus CD give rise to AD plus CB. पॉजिटिव एलिमेंट हमेशा पहले लिखा जाता है। ओके, जितनी भी डबल डिस्प्लेसमेंट रिएक्शंस होती हैं वो मोस्टली प्रेसिपिटेट रिएक्शंस होती हैं, उसमें प्रेसिपिटेट फॉर्म पड़ता है। प्रेसिपिटेट इज व्हेन टू एक्वस सॉल्यूशन रिएक्ट टू गिव राइज अ सॉलिड। सो पहला एग्जांपल Na2SO4 give rise to barium, react with barium chloride, give rise to barium sulfate which is a white PPT, white कलर की PPT होती है ये आप फिगर में भी देख सकते हैं। white solid नीचे सेटल डाउन हो जाएगा एंड एक्वस फॉर्म में NaCl का वाटर के साथ सॉल्यूशन मिलता है। यहाँ पर एक लेड आयोडाइड वाली जो रिएक्शन हमने करी थी वो भी आप याद रख सकते हैं। रिकॉल एक्टिविटी है 1.2 की जिसमें हमने PbNO3 ट्वाइस को पोटेशियम आयोडाइड से रिएक्ट कराया था तो PbI2 प्लस KNO3 फॉर्म हुआ था। दिस पोटेशियम आयोडाइड इज white yellow PPT and it is also a double displacement reaction. double displacement reactions में दोनों compounds होते हैं। so ये these are the four main types of reaction. next type of reaction is oxidation reaction and reduction. so oxidation reactions में आपको points याद रखने हैं कि oxidation addition of oxygen, removal of hydrogen और gain of इलेक्ट्रॉन। अब बच्चे ना कंफ्यूज हो जाते हैं कि गेन ऑफ इलेक्ट्रॉन लिखना है कि लॉस। ऑक्सीजन O का मतलब इसमें एडिशन ऑफ ऑक्सीजन है, ये याद हो गया। एडिशन ऑफ ऑक्सीजन, ऑक्सीजन ना नेगेटिव आयन बनाता है, नेगेटिव मतलब O2 नेगेटिव बनता है तो इसका मतलब ये गेन करता है। जो नेगेटिव आयन होते हैं वो इलेक्ट्रॉन गेन करते हैं तो आपको सीधा याद रखना है गेन ऑफ इलेक्ट्रॉन। और एक बार आपने ऑक्सीडेशन याद रख लिया, रिडक्शन उसका जस्ट अपोजिट है। तो रिडक्शन में पहला पॉइंट क्या हो गया, रिमूवल ऑफ ऑक्सीजन। सेकेंड पॉइंट एडिशन ऑफ हाइड्रोजन हो गया एंड लॉस ऑफ इलेक्ट्रॉन हो गया। सो डेफिनेशन में आप तीनों पॉइंट्स मेंशन करेंगे। अगर आए डिफाइन ऑक्सीडेशन, ऑक्सीडेशन इज अ chemical process where oxygen is added to a substance, either oxygen is added or hydrogen is removed or there is a gain of electron. ठीक है। next similarly you can do the same for reduction. now figure 1.10 this is also one of the important figure. इसके अंदर आपको याद रखना है कि आप कॉपर पाउडर आपने यूज किया है और उससे आपका एक ब्लैक कलर का कंपाउंड बन रहा है कॉपर ऑक्साइड। ये इस कलर में ना मैक्सिमम बच्चे गलत करके आते हैं, ग्रीन कलर लिख के आते हैं। कॉपर जो एटमॉस्फेयर में सल्फर प्रेजेंट होता है उसके साथ मिलके एक ग्रीन कलर की लेयर बनाता है जो आपके कॉपर यूटेंसिल्स के ऊपर यूजुअली आपको दिखती है और जिसको आप लाइम से, नींबू से या लेमन से रब करते हैं तो रिमूव भी हो जाती है। लेकिन अगर आपसे कॉपर ऑक्साइड का कलर पूछेंगे तो दिस इज ब्लैक। सो रिमेंबर CuO कॉपर ऑक्साइड इज ब्लैक इन कलर। यहाँ पे आपने कॉपर का ऑक्सीडेशन किया, कॉपर में ऑक्सीजन को ऐड किया और अगेन जब इस कॉपर ऑक्साइड को हम हीट करते हैं इन द प्रेजेंस ऑफ हाइड्रोजन गैस तो ये मुझे दोबारा से क्या दे देता है, कॉपर दे देता है। और इस रिएक्शन के लिए भी आपको एक पॉइंट याद रखना है कि जो ब्लैक कॉपर ऑक्साइड था उसका कलर चेंज हो जाता है टू ब्राउन। ओके, सो यहाँ पे कलर चेंज की भी पॉइंट है जो आपको याद रखना है कि जब कॉपर ऑक्साइड को आप हाइड्रोजन से ट्रीट करते हैं तो इट गिव्स यू ब्राउन कलर कॉपर, कॉपर का कलर ब्राउन होता है। ठीक है, सो दिस इज वन। नेक्स्ट इज रिडक्शन। आपको क्लियर हो गया, यहाँ पर आपका रिडक्शन हुआ है क्योंकि यहाँ पर क्या ऐड हुआ है, हाइड्रोजन गैस। पहले वाले में ऑक्सीजन गैस थी तो ऑक्सीडेशन, दूसरे वाले में हाइड्रोजन गैस है तो रिडक्शन। ठीक है, तो ये दो हमारे एग्जाम्पल। समटाइम्स एक ही रिएक्शन के अंदर दोनों पॉइंट साइमल्टेनियसली हो रहते हैं। when oxidation and reaction occur simultaneously in one reaction such are known as redox reaction। ये फेवरेट टॉपिक है CBSE का, इस पे सबसे ज्यादा क्वेश्चंस पूछे जाते हैं। सो रिडक्शन रिएक्शन की डेफिनेशन हो गई फर्स्ट तो, when oxidation and reduction occur simultaneously it is called redox reaction। सेकंड इसका एग्जाम्पल हो गया. So the first example here is when copper oxide react with hydrogen gas give rise to copper and water. Now अगर आप देखेंगे तो यहाँ पे H था और जब राइट हैंड साइड पे पहुंचा तो वो H2O हो गया, मतलब हाइड्रोजन के अंदर ऑक्सीजन ऐड आ गई. तो हाइड्रोजन में जब ऑक्सीजन आई तो हाइड्रोजन का क्या हुआ, ऑक्सीडेशन. इसी तरह कॉपर में लेफ्ट हैंड साइड पे ऑक्सीजन है जिसमें से ऑक्सीजन रिमूव हो जाती है जब वो राइट हैंड साइड पे पहुंचता है. तो रिमूवल ऑफ ऑक्सीजन इज रिडक्शन. तो इस रिएक्शन में दोनों चीजें एक साथ हो रही हैं. यहां पर नेक्स्ट पॉइंट पूछा जाता है रिड्यूसिंग एजेंट और ऑक्सीडाइजिंग एजेंट. रिड्यूसिंग एंड ऑक्सीडाइजिंग एजेंट. अब रिड्यूसिंग एजेंट कौन होता है? रिड्यूसिंग एजेंट वो होता है जो ऑक्सीडेशन में हेल्प करेगा. ठीक है, तो उल्टा होता है, याद रखने के लिए, इट हेल्प इन ऑक्सीडेशन. तो रिड्यूसिंग एजेंट क्या करता है, ऑक्सीडेशन में हेल्प क्या करेगा, ऑक्सीजन दे देगा. तो यहाँ पर ऑक्सीजन कौन दे रहा है, कॉपर ऑक्साइड दे रहा है. तो रिड्यूसिंग एजेंट कौन हो गया, कॉपर ऑक्साइड. बेसिकली जिसका रिडक्शन होगा वो रिड्यूसिंग, सॉरी उल्टा बोल दिया हमने, चेंज इट. रिड्यूसिंग एजेंट आपका वो होगा जो कि हेल्प करेगा इन रिडक्शन में जो हेल्प करेगा. तो रिडक्शन में हेल्प कौन कर रहा है यहाँ पे, आपके रिडक्शन में हेल्प कर रहा है हाइड्रोजन गैस. तो हाइड्रोजन गैस जो है वो ऑक्सीजन को लेके जा रही है, राइट, जिससे कॉपर का ऑक्साइड का क्या हो रहा है, रिडक्शन. और ऑक्सीडाइजिंग एजेंट कौन होगा, जो जिसका ऑक्सीडेशन होगा. ठीक है, जो रिड्यूस हो जाएगा धीरे से. तो यहाँ पर आपका ऑक्सीडाइजिंग एजेंट कौन है, CuO. ऑक्सीजन इसने ऑक्सीडाइजिंग में आपकी हेल्प करी है, ऑक्सीडेशन में कैसे हेल्प करी है, जो अपना ऑक्सीजन है वो दे के हेल्प करी है. तो जिनका रिडक्शन होता है वो ऑक्सीडाइजिंग एजेंट बन जाते हैं क्योंकि वो ऑक्सीजन दे देते हैं और दूसरे मॉलिक्यूल को ऑक्सीडाइज कर देते हैं. और जिनका ऑक्सीडेशन हो रहा है वो रिडक्शन में हेल्प करते हैं. क्या हेल्प करते हैं, ऑक्सीजन ले लेते हैं. तो यहाँ पर आपका रिड्यूसिंग एजेंट कौन हो गया, H2. ठीक है, तो H2 ने क्या ले लिया, ऑक्सीजन ले लिया कॉपर ऑक्साइड से. आपको इसी तरह रिडॉक्स की दो और रिएक्शन दी गई है. ZnO प्लस कार्बन गिव राइज टू कार्बन मोनोऑक्साइड एंड जिंक. Another MnO2 plus 4HCl give rise to Mn chloride, manganese chloride, water and chlorine. अब इसमें रिडॉक्स और ऑक्सीडेशन एंड रिडक्शन आइडेंटिफाई करना भी आ जाता है. तो लेट्स आइडेंटिफाई. पहले ZnO का एग्जांपल ले लेते हैं. जिंक ऑक्साइड को जब आप कार्बन के साथ ट्रीट करते हैं तो उसका क्या हो जाता है, रिडक्शन, और वो बन जाता है जिंक और साथ में रिलीज करता है कार्बन मोनोऑक्साइड गैस. अब कार्बन के साथ ऑक्सीजन जुड़ रहा है तो इट इज ऑक्सीडेशन रिएक्शन. और जिंक में से ऑक्सीजन रिमूव हो रहा है, सो दिस इज रिडक्शन रिएक्शन, पहला स्टेप. अब आपसे एजेंट और बताने हैं. अगर आपको रिड्यूसिंग एजेंट बनाना है तो रिड्यूसिंग एजेंट कौन है, जो ऑक्सीडेशन में हेल्प कर रहा है. और ऑक्सीडेशन में हेल्प कौन कर रहा है आपका, कौन लेके जा रहा है ऑक्सीजन को अपने साथ, कार्बन. सो कार्बन मोनोऑक्साइड इज योर रिड्यूसिंग एजेंट हियर, क्योंकि वो अपने साथ क्या ले गया, ऑक्सीजन को ले गया. ऑक्सीडाइजिंग एजेंट, ऑक्सीडाइजिंग एजेंट कौन हो जाएगा, ऑक्सीडाइजिंग एजेंट हो जाएगा आपका, जो कि आपको रिडक्शन में हेल्प करेगा। और रिडक्शन में कौन हेल्प कर रहा है? जिंक ऑक्साइड्स। कैसे हेल्प कर रहा है वो? ऑक्सीजन दे के हेल्प कर रहा है। लेट्स मूव टू नेक्स्ट टॉपिक। नेक्स्ट एंड लास्ट टॉपिक ऑफ द चैप्टर इज corrosion and rancidity. corrosion is oxidizing of metals, ठीक है। तो जब metals ऑक्सीडाइज होते हैं तो we call them corrosion, ठीक है। तो सभी मोस्ट ऑफ द मेटल्स ऑक्सीडाइज और वो अलग अलग होते हैं, बट जो सबसे कॉमनली होता है दैट इज आयरन, ठीक है। तो जब आयरन कोरोड होता है तो वी ऑल्सो कॉल इट रस्टिंग ऑफ आयरन। अब रस्टिंग ऑफ आयरन से आयरन की एफिनिटी कम हो जाती है, उसकी स्ट्रेंथ कम हो जाती है, वीक हो जाता है वो। तो उसको प्रिवेंट करने के लिए हमें उसके ऊपर कोटिंग करनी पड़ती है अनदर मटेरियल की, एंड उसको हम कहते हैं इलेक्ट्रोप्लेटिंग। इसके अलावा आप उसको पेंट करके, ग्रीसिंग करके, ऑयलिंग करके भी प्रिवेंट कर सकते हो। एक बहुत ही कॉमन होता है जब आयरन के ऊपर आप जिंक की कोटिंग करते हैं, तो उस प्रोसेस का नाम हो जाता है गैल्वेनाइजेशन। ये डेफिनेशन भी आप याद रख सकते हैं। गैल्वेनाइजेशन इज नथिंग, इट इज अ इलेक्ट्रोप्लेटिंग प्रोसेस वेयर जिंक इज कोटेड ओवर आयरन। ओके, इसके अलावा फ्यू मोर सब्सटेंस है जिनकी ऑक्सीडेशन होती है। जैसे सिल्वर की ऑक्सीडेशन होती है तो ब्लैक कोटिंग बनती है, कॉपर की ऑक्सीडेशन होने पे ग्रीन कोटिंग बनती है। लेकिन इसको आप कॉपर ऑक्साइड से कंफ्यूज नहीं करेंगे। कॉपर को जब हीट करते हैं तो कॉपर ऑक्साइड बनता है, और ये यहाँ पर ग्रीन कोटिंग सल्फर की वजह से हो जाती है। इसी तरह इसमें एक सिल्वर का आप याद रखेंगे, ठीक है, ब्लैक कलर की कोटिंग हो जाती है उसके ऊपर। ओके, नेक्स्ट इज रेंसिडिटी। रेंसिडिटी इज ऑक्सीडेशन ऑफ फूड। वो था मेटल्स का, ये है ऑक्सीडेशन ऑफ फूड आइटम्स। जब आपका फूड मटेरियल्स ऑक्सीडाइज हो जाते हैं तो उनको रेंसिडिटी कहते हैं। रेंसिडिटी से उनकी क्वालिटी खराब हो जाती है, लाइक जो नॉर्मली हम चिप्स वगैरह खाते हैं वो उतने क्रंची नहीं रहते हैं अगर उनका ऑक्सीडेशन हो जाता है। ऑयल्स वगैरह का ऑक्सीडेशन होता है तो स्मेल आने लगती है, ठीक है। यहाँ पे रेंसिड वर्ड मेंशन होगा। रेंसिड मतलब वो खराब हो जाते हैं और उनमें से स्मेल आती है। तो इससे प्रिवेंट करने के लिए हम उनको एयर टाइट कंटेनर्स में रख सकते हैं। नाइट्रोजन गैस को फ्लश कर सकते हैं हम चिप्स के अंदर टू रिटेन देयर क्रंचीनेस एंड फ्रेशनेस। प्रिजर्वेटिव्स का यूज कर सकते हैं। आपके ऑयल्स को प्रिवेंट करने के लिए आप उनको एंटीऑक्सीडेंट्स भी उनके अंदर डाल सकते हैं जो ऑक्सीडेशन को प्रिवेंट करते हैं। क्लियर? सो दिस इज द अबाउट this chapter number 1, chemical equations and equations and reactions. Hope this help you at the end. Thank you. See you tomorrow with the next chapter. Hello students, welcome to Momentum Masters. At Momentum Master, we believe that success in CBSE is not about studying more. It's about studying with the right thing. So let's start our chapter 2, acid, bases and salts from NCERT. This chapter is not about theory, it is about experiences you had every day. The sour taste of lemon, the bitterness of medicines, slippery texture of soap, all of this is chemistry. So keep your NCERT open because today we'll study the same chapter. And remember, strong concept create confidence and confidence create result. So let's begin. The first page of the chapter tells you about previous knowledge of yours toward acid, bases and salt. This previous knowledge tell you which substances are sour, which are bitter, and what remedy you should use at the time a person is suffering from acidity, the nullify character of acids and bases, about litmus papers, and some natural indicators like turmeric, uh, hydronic and geranium, and some synthetic indicators like methyl orange and phenolphthalein. So before moving further, let's distinguish between acids and bases. Acids. Acids are those substances which give H positive ions in water. So this is also definition of acids. They are of two types, weak acids and strong acids. Let's remember few examples for them. Weak acids are generally natural and natural food organic acids like CH3, COOH, acetic acid or ethanoic acid. Strong acids are also known as mineral acids like HCl and H2SO4. HCl is hydrochloric acid, H2SO4 is sulfuric acid. Now this weak CH3 is organic acid, and the strongs are also known as mineral acids. Okay. Now further there are other two types of acid like diluted acids and concentrated acid. Concentrated acids. So diluted acids are where acid is in less quantity, and in concentrated, sorry, I got it. In diluted acids is in less quantity, and in concentrated acids is in more quantity. Acids are corrosive, they causes burn. Also, uh, they are they turn red litmus, blue litmus to red. They turn blue litmus to red. Okay, they turn blue litmus to red litmus. These are few points about acids. Okay, next the pH. pH is also one of the important point. They had a pH less than 7. Smaller pH, strong acids. Smaller pH indicates strong acids. Okay, now let's talk about bases. They give OH negative ion in water. They are also weak bases and strong bases. Weak are like NH4OH, ammonium hydroxide. Strong are like NaOH, KOH, sodium hydroxide, potassium hydroxide. Okay, and water solubility. There are only few bases which are soluble in water, and those are known as alkalis. Water soluble bases. So all bases are not soluble in water, but all acids are soluble in water. Yes, few strong bases are also corrosive. However, weak bases are not. They are slippery in texture. Remember, soaps slippery texture, they are slippery in textures. They have a pH greater than 7. Higher pH indicate strong bases. Okay. About electricity, both conduct electricity because both dissociate into ions form when in contact with the water. So they both are basic in they both are good conductors of electricity. Let's study about some uh, indicators, natural and man-made indicators. Okay. Here chemical properties of acid base. Before starting that, they were telling you about in activity number 1, like hydrochloric, sulfuric, nitric acid, acetic, sodium hydroxide, potassium hydroxide, ammonium hydroxide. अभी हमने सब पढ़ लिया. Their behavior with the red litmus, blue litmus, phenolphthalein and methyl orange. Okay. In activity 2.2 they were talking about, so these are litmus and um, phenolphthalein, methyl orange, like mineral acid. Laboratory indicators, behavior of acid base with the litmus and laboratory indicators. And in activity 2 they were talking about natural indicators. So let's move further with the indicators, how indicators are being compiled. Okay, let's study that. Okay, so let's make a table on indicators. First, what are indicators? Indicators are those substances, natural or man-made, which change their properties when it comes into contact of acid, bases and neutral substances. Okay, so first, natural indicators. Natural indicators are like litmus, turmeric, China rose. These all are natural indicators. Okay, then you have some man-made indicators, yeah, laboratory indicators like phenolphthalein, methyl orange, okay, and universal indicator pH paper, some olfactory indicators. Olfactory indicators are those indicators which change their smell. Okay, about to change their color. So these are color changing indicators, and olfactory is about smell changing indicators. Okay, olfactories are like onion, vanilla, clove oil, okay. Let's distinguish on the basis of acids and salts, acids and bases, which color they give into acids. In acid, litmus is red in color, so blue will turn red and red will remain red. Turmeric will be yellow, no change. Okay. China rose is dark pink, ya magenta. Okay. Phenolphthalein, phenolphthalein is colorless. Methyl orange, it turns red. यूनिवर्सल रेड और ऑरेंज कह सकते हैं आप इसको, ठीक है, रेड एंड ऑरेंज. नेक्स्ट इज olfactory, it retain its smell. It it also vanilla also retain its smell, and clove oil. All olfactory indicators retain its smell when they come into contact with acid. Now let's talk about bases. Okay, bases, they turn red litmus to blue, or blue remains blue. As the simple way to remember is B for bases, B for blue, B for bitter. Okay, so bases are bitter. Another one is sour. Okay, next is about turmeric. They turn turmeric into reddish brown color. Okay, next is China rose. They turn China rose into green. Phenolphthalein into pink, methyl orange into yellow, universal indicator into blue or purple, strong will look like purple, and the weak bases will look blue. Their smell disappears. In olfactory, when olfactory indicators come into contact with bases, their smell disappears. All of three. Okay, this is all about indicators and their action with acid and bases. This is one of the favorite topic of CBSE. They used to ask the change of color, or what are indicators into their paper. So remember this table. Let's move to next page. Now we are starting our chapters chemical properties. Till now we have studied the physical properties of acid, bases and salt. Now we are starting with the chemical properties. So chemical properties, first is reaction of acid bases with the metals. How acid bases react with metals? So activity 2.3 will give you a brief about metals reactions with acids and bases. For that we have taken zinc granules. We are taking zinc granules and pour diluted sulfuric acid into the test tube, cover the test tube and extract the gas to soap solution. And from soap solution the gas is evolving out and it is burning with pop sound, hence it is hydrogen gas. So we can say that acid reacts with metal to produce salts and hydrogen gases. So the generalized reaction is acid plus metal give rise to salt plus hydrogen gas. Let's take few examples of the same. Mg, a metal, reacting with HCl give rise to MgCl2 plus H2. Take one more example from activity 2.3. Zinc, when reacting with H2SO4 dilute sulfuric acid, it forms ZnSO4 plus H2. Okay. These reactions are not balanced. Let's balance them first. Now you have two HCl molecules to balance this two, and 2Cl. Now it is balanced. Okay, 2 Mg plus 2 HCl give rise to MgCl2 plus hydrogen gases. Okay, and hydrogen gas burns with popping sound. This is the favorite activity of CBSE. It is an important activity. Remember it. They multiple times ask you this activity, how you can test the hydrogen gas presence in a reaction. Next, acids metals reaction with your before going further, let's parallelly study about the bases reaction with the acids. How bases reacts with metals. So the generalized equation is when base react with metal, it also produce salt plus hydrogen gas. Okay, it also produces hydrogen gas. There are two important reactions here. One is NaOH reacting with zinc to produce a salt Na2ZnO2 plus hydrogen gas. This is sodium zincate. Okay, this is sodium zincate. It is one of the important reaction. When bases react with zinc, they produce sodium zincate. One of favorite reactions of CBSE, because they multiple time ask about it. The activity 4 gives you the relation of reaction of bases with the metals. There is one more reaction here. When sodium hydroxide react with uh, aluminium, the important reactions, write down aluminium reacting with NaOH, and this reaction happens in the presence of water and it gives rise to NaAlO3 O2 plus hydrogen gas. Let me balance it. So this is 2 NaOH. Now it is balanced. Yeah. One oxygen here, two oxygens here. So two add aluminium, 2 on left hand side. So this is a balanced reaction. In this reaction, sodium aluminate is produced. So these two reactions, basis reaction with metal, both reactions are important. This is your sodium aluminate. In general, if you want to remember a point, you just remember this: acid, either acid or bases reacting with metal, both produce salt with hydrogen gas. Okay, both produce hydrogen gas. Let's move further. Reaction of acids and base with metal carbonates and metal hydrogen carbonates. Metal carbonates are M2CO3. Yeah, basically MCO3. MCO3, and metal hydrocarbonates are MHCO3. Now metal carbonate reaction of acids with metal carbonates are like, when a acid reacting with metal carbonate, it produces salt plus water plus carbon dioxide gas. And when they are reacting with metal hydrogen carbonates or bicarbonates, MHCO3, they again produce salt plus water plus CO2 as gas. In both the reactions, product are same: metals, salt, water and carbon dioxide gas. Activity 2.5 give you the same reactions like when Na2CO3, this is sodium carbonate. When sodium carbonate react with an acid HCl, it gives you a salt, water and CO2 gas. One more example with bicarbonate, sodium hydrogen carbonate. Sodium hydrogen carbonate. Okay. Sodium hydrogen carbonate reacting with HCl produce salt, water and carbon dioxide gas. Next comes activity of testing the presence of CO2 gas. So to test the presence of CO2 gas, this gas is allowed to pass through lime water. or CaOH whole twice calcium hydroxide. Yes, this is the same calcium hydroxide which is formed during our process whitewashing. Okay, when quicklime react with water to produce calcium hydroxide through an exothermic reaction. CaOH whole twice reacting with carbon dioxide give a compound CaCO3 calcium carbonate, which is responsible for the shining of room walls after whitewash. It is also a white precipitate. Precipitate are those substances which are insoluble in water and releases water. So basically, when CO2 passes through it, the solution turns milky. Okay, CaCO3, okay, the solution turns milky. But if excess carbon dioxide is passed, here it is reaction, it further reacts with calcium carbonate to produce calcium hydrogen carbonate, which is soluble in water, hence milky color disappears. Okay, these two are favorite topics of CBSE. Just remember these two reactions, that first calcium carbonate will form and then calcium hydrogen carbonate is formed. Calcium hydrogen carbonate is soluble, so milky color disappears. Okay, calcium carbonate comes into limestone, chalk and marble form. So this is your generalized reaction. Metal carbonate or hydrogen carbonate, both reacting with acid give rise to salt, carbon dioxide and water. For the presence of carbon dioxide, you react it with calcium hydroxide, and this calcium hydroxide produces CaCO3, which is milky in color. And then if excess CO2 will pass, if you further react with the CO2, it give rise to CaHCO3 OH. Now this is colorless, so the color will disappear. So this is the reaction of acids with metal carbonates or metal hydrogen carbonate. Next is acids bases reacting with each other. Before going to this topic, let me tell you, as metal carbonate and metal hydrogen carbonate do not react with bases. Plus bases, no reaction. Okay, remember this point. Metal carbonate will not react with bases. Na2CO3 plus NaOH, no reaction. Move further with acids and base. When acids react with bases, it gives neutralization reaction, where both reduces each other's character. When a base react with acid, it produces salt plus water, and this type of reaction is known as neutralization reaction. It is very important in our day-to-day life. One example of such is NaOH reacting with HCl give rise to NaCl and water. So this is your reaction. In this topic, you have to remember there are four types of salt. When a strong, three types of salt. When a strong acid react with strong base, as the example indicate. Okay, so they produce a neutral salt. Similarly, when a weak acid react with weak base, it also produces a neutral salt. In both the conditions, the salt produces neutral in character. It does not turn the pH. But when a strong acid reacting with a weak base, it produces a acidic salt plus water. And when a weak base, a weak acid reacting with strong base, it produces a basic salt plus water. Take one example of these two strong acids like HCl reacting with weak base NH4OH. A acidic salt is produced NH4Cl plus H2O. This is its example. Similarly, when a weak acid reacting with strong base NaOH, a strong base reacting with CH3COOH, acetic acid or ethanoic acid, which is organic acid, has weak acid, it produces CH3COONA plus H2. Sodium ethanoate, sodium ethanoate its name, and it is a basic salt. It is basic salt. Let's move for the reaction of acids with metal oxides. When a metal oxide reacts with acid, it produces salt plus water. Blue-green color of solution of copper chloride in this reaction will form when a copper oxide react with hydrochloric acid. Okay, यहाँ पर copper oxide CuO reacting with HCl, it gives rise to CuCl2, which is blue-green color, blue-green in color plus water. Okay, so this blue-green color compound, remember this salt CuCl2. A reaction of non-metallic oxides with bases, carbon dioxide and calcium hydroxide, as mentioned in previous activity. You can see calcium hydroxide is a base reacting with carbon dioxide to produce a salt and water. Okay, calcium hydroxide CaOH whole twice reacting with CO2 to produce CaCO3 plus water. They are talking about this reaction, non-metallic oxides with bases. Okay. Further, acids and bases, what they have common into them. So this is another one important point. What is the common between acids and bases? Acids and bases both dissociate in water. When they are dissolved in water, both dissociate in water. Acid gives H positive ion and bases give OH negative ion. Hence both conduct electricity. Both will conduct electricity. Here acids give H positive ions as cation and anions. Similarly, HNO3 gives nitric ion and this gives sulfate ions. This gives CH3COO negative as an anion, okay, in water, and bulk will grow. They both conduct electricity. One more important topic, what happens when an acid and base is dissolved into water? Acid और bases को आप water में dissolve करेंगे तो क्या होगा? Always add acid into water. Acid in water, not vice versa, because addition of acid is a exothermic reaction. So when you add acid in water, when you add water in acid, it will splash and causes burning to the scientist. Okay, yeah, you. basically. Always add acid into water drop by drop and constantly stir it so that it will get dissolved, properly dissolved, and you will form a diluted uh, acid. So the next point from the activity 2.9 is what will happen if you test a dry litmus paper and a wet litmus paper uh, with during the condition when sodium chloride is reacting with a acid. Sodium chloride is a salt. When NaCl reacts with H2SO4, it produces HCl. The HCl, this activity tells you that you pass the dry acid over the litmus paper. It does not change its color. Dry, no change in color, whereas when you treat HCl, a wet HCl, reaction of HCl with water produce hydronium ion and chloride ion. These hydronium ions, basically how they produce, they take H positive ion from the water and becomes hydronium ion. When these hydronium ions comes into contact with litmus, they turns red. So this activity shows that acidic behavior is only in presence of water. They usually ask one MCQ, will dry HCl change the litmus color or HCl solution? So dry HCl gas, no change, and litmus solution turn it to red, blue to red, and keep red into red. Let's move further about bases. How bases will react? When bases dissolved in water, they produces OH negative ion, and this OH negative ion will help them into giving their color. Also, all bases do not dissolve in water, only alkalis dissolved into water. Further, acid and base reacting with salt produce water. The X part of the acid, like mineral part of the acid, reacting with the metal part of the base and produce a salt, and water is released. H positive ion and OH negative ion combines to give water. It is an exothermic reaction. Temperature increases. Activity 2.10 shows you an exothermic reaction, and that reaction of acids with water, acid or bases with water, is the exothermic reaction. Hence we always add acid to water, not water to acid. Now the next topic, how strong acid base solutions are. So this for that we have developed a scale measuring the hydrogen ion concentration in the solution. It is named as pH scale, which start from 0 and reach to 40. 7 is treated as neutral point. So water has neutral pH. Okay, as you move towards the 0 side, hydrogen ion concentration increases, or we can say acidic character increases, basicity reduces. Okay, whereas on the opposite side, when you move towards 14, basic nature increases, hydrogen ion concentration decreases, or acidic character also reduces. Acidic character reduces. Okay, few more things about this pH table. If you have a solution of pH 10 and you have a solution of pH 6 and you have a solution of pH 3 and one solution of pH value 30. It is strong base, 10 is a base, medium base. When you move more closer to 7 like 8, it's a weak base. Similarly, when you move lower to 7 like 6, it is a weak acid, whereas 3 is strong acid. So, by looking at the pH value, you can tell about the strength of the acid or alkali. Let's move further. Okay, activity 2.11. Here pH values of solutions, you have to note it down in table 2.2 and record your observations, color change with the pH. Now few more few examples like sodium hydroxide solution, NaOH solution has a pH about 14. Milk of magnesia, eno component, it has a basicity of 10, its pH value is 10. Pure water or blood has a pH value 7.4, neutral. Lemon juice, it's 2.2. 5. Coffee is 5. Gastric juices, which is inside your stomach, HCl, it's about 1.2. So these are few examples of common substances used in day-to-day life and their pH values. You have to remember them. And also notice the color of pH paper. It was red in color at 0 value and it's almost blue or purplish blue at number 14. Now let's talk, okay, all these solutions will always sensitive when they are in wet state or they have a water content with them, only then they will respond to pH paper. Next is importance of pH in everyday life. Plants, animals, everyone is sensitive to pH values. Like our body, it works on the pH range of 7 to 7.8. So human bodies are slightly basic, they are towards basic. They can survive in this range only. pH of rainwater is 5.6. That's why we call it acidic rain. Acid rain flows into water and river water pH also change, and this change cause danger to aquatic life. Okay, next, pH of soil. Before that, acids in other planets, acidic rain in other planets. Venus atmosphere has a thick white and yellowish cloud of sulfuric acid. Hence, that is the reason there is no life on Venus, because there is an acid rain due to sulfuric acid present into their atmosphere. Also remember, the sulfuric acid color is thick yellow, thick white and yellowish color. Now about soil. Plants are also very sensitive towards the pH value. Hence, for the good growth of plants, the pH should be maintained. So, if soil pH is acidic, then add calcium carbonate to it to balance it. So, it is a physical significance of neutralization reaction. Similarly, if pH value of soil is basic, then add humus to it. Manure, basically humus is manure. It's organic and it has slight acidic character. Now activity 2.12. It states 2 gram of soil in test tube and check its pH and then give the required solution mentioned here. Next, third is pH in our digestive system. Our digestive system works better for the protein decomposition with the hydrochloric acid whose pH is 1.2. So if the pH is above 1.2, it will cause disturbance in protein absorption. Okay, so that's why we were asked not to drink coffee, not to drink coffee after food. Although coffee is acidic, it is acidic, but still it has a pH of around 5. So by drinking coffee, it will raise the pH level in stomach. And make it less acidic, because stomach pH is 1.2 and coffee pH is 5. So resultant pH value will be a little higher and hence absorption of protein hinders. So, and another one, indigestion situation, when this HCl produces in stomach raise to other portions, causes pain and irritation. To neutralize this effect, we need to take antacids. One of such antacid is magnesium hydroxide, also known as milk of magnesia, present in ENO. Next example is tooth decay. The use after eating food, the pH of mouth lower downs to 5.5, which is acidic in character, and the enamel is made up of calcium hydroxide, a crystalline of calcium phosphate. Okay, it is hardest substance present in the body, not on the earth, in the body. Okay, it does not dissolve in water, but corroded due to this pH. Below pH may this enamel starts getting corroded. To prevent it, we need to use toothpaste, which are slightly basic, hence neutralizing the acidic character of our mouth. Next come self-defense of animals and plants through chemical warfare. Some plants and animals releases some chemicals to in self-defense, like bee stung, honey bee stung. It has an acid due to which your skin cause irritation and pain. To neutralize it, you should use baking soda. Okay, it sting nettle sting has methanoic acid. Okay, CHCOOH, HCOOH. It is the formula of methanoic acid. Here few things are mentioned, few natural sources, like vinegar has acetic acid. It is also known as ethanoic acid, CH3COOH. Orange has citric acid, tamarind has tartaric acid, tomato oxalic acid, curd lactic acid, lactose in milk converted into lactic acid during fermentation of milk. Then lemon also has citric acid. Maximum sour fruits are having citric acid. Ant sting and nettle sting has methanoic acid. Just remember here that wasp sting is basic in character. Hence, when the wasp bite you, stung you, then you need to apply lemon onto it. Whereas when ant or nettle stings, then you should apply soap to reduce its effect. Okay, it is a nettle is a plant which grows in wild, and when you touch it accidentally, it releases methanoic acid. To reduce it, a traditional remedy, leaf of dock plant is rubbed over it because that has a basic character into it. Here are few questions. You have two solutions A and B. The pH of solution A is 6 and the pH of solution B is 8. Which solution has more hydrogen ion concentration? We knew that for acidic character to increase, we should move towards zero side. So it has more hydrogen ion compared to 8, and if they ask which one is basic, then B is basic. Second question, what effect does the concentration of H positive ions have on the nature of solution? More H positive, it is acidic. Less H positive, it is basic. Clear? Then do basic solutions have H positive ions? If yes, then why are these basic? Yes, they have H positive ion, but still they are basic because they have more H positive ions, OH negative ions. They have more OH negative ions, less H positive ions, hence they are called basic. Next is, under what soil condition do you think a farmer treat the soil for his fields with quicklime or calcium oxide or slaked lime or calcium carbonate? It should be done when your pH is more than less than 7, when your pH is less than 7. Basically these all are bases. When your pH of the soil drops below 7, it is acidic, then you should treat it with the bases to neutralize its effect. Now the next part of the chapter is about salts. We were going to study family of salts and few salts. There are some components mentioned in activity 2.13 like potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate and ammonium chloride. Let's name them, the chemical formula. First is potassium sulfate, K2SO4. Next is sodium sulfate, Na2SO4. And next calcium sulfate, CaSO4. Magnesium sulfate, MgSO4. Next is copper sulfate, CuSO4. Sodium chloride, NaCl. Next is sodium nitrate, NaNO3. Next sodium carbonate, Na2CO3. And ammonium chloride, NH4Cl. These all are salt. First 5 are the members of sulfide family. This is a member of chloride family. NH4Cl also chloride family, and NaNO3, and these are nitrite family, and these are carbonate family. Nitrate and carbonate. Nitrate and carbonate families. Okay. If you know the salt name, you can tell the parent acid and base. Parent acid and base. Let's take first example, K2SO4. So acid will be H2SO4. To identify the parent acid, always look towards the negative ion present into the solution, yeah, salt. So this is also H2SO4, this is H2SO4, and GSO4 is also H2SO4. This is also H2SO4. NaCl, it is made up of HCl, NaNO3, it is HNO3, nitric acid, Na2CO3, is H2CO3, carbonic acid, and again it is HCl. Now for telling the base, parent base, look at the positive ion, it is KOH. Second is NaOH. Ca is CaOH whole twice. Calcium hydroxide, magnesium hydroxide, copper hydroxide, NaOH, sodium hydroxide, NaOH, carbo, uh, sodium hydroxide, or carbonate is also NaOH. The last one is NH4OH, ammonium hydroxide. In the next activity mentioned on the second page, activity 2.14, pH of salts. By looking at the components, like which parent acid and base is used for that particular salt, you can tell the characteristic of that salt. Now in K2SO4, potassium sulfate, as you can see, it is a strong acid as well as strong base, hence the pH of the salt is neutral. In the second example, sodium sulfate made up of sulfuric acid and sodium hydroxide, again both are strong, hence the salt is neutral. For calcium sulfate, it is parent is strong, it is a mild one, okay, less stronger than sulfuric acid, hence it is slightly acidic, because here you have used a strong acid for its formation. Magnesium sulfate, it is acidic salt because it has a weak base. Copper sulfate, it is also acidic salt because the sulfuric acid is used, and sulfuric is a strong acid. HCl is also a strong acid, NaOH is also a strong base. Both are strong, hence it is neutral in character. When HNO3 and NaOH is compared, then you can say it is a basic salt. When carbonic acid is compared with NaOH, it is stronger and it is weak. Hence, the salt is basic in character. Last, ammonium hydroxide, it is a weak base, whereas HCl is a strong acid, hence the salt formed is a acidic salt. This way you can identify the parent acid, base, and the character of salt. Remember one point, the salt character will always show when salt is in wet state. You have to mix the salt into water and then you have to check its pH. Last topic of the chapter, and an important one, because you will always get a question from this section. It involves some chemicals formed from the common salt. Common salt is sodium chloride. It's sodium chloride. Formula is NaCl. So by using NaCl, you are going to make some other bases. Combination of this. How NaCl you get? NaCl you will get by the combination of HCl with sodium hydroxide. It will produce NaCl due to neutralization reaction, and water is released. In aqueous state you will get it. It is mentioned here, by the combination of hydrochloric acid, sodium chloride solution, sodium hydroxide solution, sodium chloride is obtained, which is used in food. You will remove this from the sea water. Sodium chloride deposits of solid salts you will find in many parts, and we call it rock salt. When the water evaporates, It's leave behind hard, salty bed, and that is which is brown in color due to impurities, and this uh, due to impurities, and this hard salty bed is known as rock salt. After removing the impurities from it, on drying it up, you will get some NaCl, which is common salt. So one question also from here, difference between rock salt versus NaCl. NaCl is white in color, rock salt is brown in color due to impurities, both formed when water evaporates from the sea. Now, common salt is going to be our raw material for all the chemicals now listed below. So, first chemical we are going to study about sodium hydroxide. Chemical formula of sodium hydroxide is NaOH. Common name of sodium hydroxide is caustic soda. All three things mentioned is important. Sodium hydroxide, chemical name, NaOH chemical formula, caustic soda common name. Then how this sodium hydroxide is formed. The process is known as chlor-alkali process, where brine is prepared. What is brine? Brine is NaCl plus H2O. When you mix water, when you mix salt, common salt into water, you will get a solution known as brine. This brine solution, when electricity is passed through brine solution, as you see in this diagram, brine solution is entered from the left hand side, you will get chlorine gas at anode and hydrogen gas as at cathode, and NaOH is released near cathode. CBSE used to ask where NaOH is produced in chlor-alkali process. So it is produced near cathode. Reaction is when brine electricity is passed through brine solution, it dissociates to give sodium hydroxide, chlorine gas and hydrogen gas. Remembrance, as we learned in chapter 1, hydrogen gives H positive ion, and these H positive ion coagulate on cathode to produce hydrogen gas, whereas chlorine forms negative ion, they deposited on anode to produce chlorine gas. It's easy. Now what uses, you have to remember the uses of each compound formed here. So chlorine has used in water treatment, swimming pools, cleaning of swimming pools. It also acts as a disinfectant. It is used in CFCs. CFCs are used in refrigeration process, and these are responsible for ozone depletion. Remember these points also with CFCs. Chlorine also used in pesticides industries. Now hydrogen, it is a green fuel. It helps in it combines with nitrogen to produce ammonia for fertilizers. The component we started studying, caustic soda, NaOH, it is used as degreasing for metals. It is also used in soap detergent industry, paper making, and artificial fibers are produced by the help of NaOH. So the points you have to remember from the first compound is its name, sodium hydroxide, its chemical formula NaOH, its common name caustic soda. How it is prepared? It is prepared when NaCl is dissolved in water to produce brine, and when electricity is passed, it dissociates to give NaOH plus chlorine gas plus hydrogen gas. Chlorine gas is released at anode and hydrogen gas is released at cathode. NaOH is produced near cathode and the whole process is named as chlor-alkali process. And then uses of each: NaOH degreasing of metals, chlorine disinfectant, hydrogen as a green fuel. Second component is bleaching powder. Bleaching powder is produced after electrolysis of brine. Chlorine gas is used for manufacturing bleaching powder. When you pass the chlorine gas produced in the above chloralkali process through calcium hydroxide, it will produce bleaching powder known as, it gives rise to bleaching powder, correct this formula as CaOCl2. Uh, its chemical name is calcium oxychloride. Calcium oxychloride, and water is produced. Let me write it here: bleaching powder, like above it is caustic soda, it is bleaching powder. Its chemical formula is CaOCl2 and its chemical name is calcium oxychloride. It formed when chlorine gas is passed through calcium hydroxide. CaOH whole twice, calcium hydroxide, chlorine gas is passed through it to produce CaOCl2 plus CaCl plus H2O. H2O. Okay. Then uses of bleaching powder. Bleaching powder is used as a bleaching agent in textile industry. It is used in paper factories to bleach the wood pulp. It is also used for bleaching washed clothes in laundry for removing hard stains. It acts as an oxidizing agent in chemical industries as oxygenates is a part of this compound. It is also used for drinking to kill the germs present in the drinking water. Third main compound is baking soda. Baking soda is Na2CO3. Okay. Its chemical name is sodium. Oh, let me change it. Baking soda, the baking soda chemical formula is NaHCO3 and chemical name is sodium hydrogen carbonate या फिर sodium bicarbonate, we also call it sodium bicarbonate. It is formed when two gases pass through brine solution, carbon dioxide and ammonia. When carbon dioxide and ammonia is passed through brine solution, it will give rise to salt NH4Cl. If you remember, NH4Cl is a acidic salt. It's acidic salt and it gives a base NaHCO3. It's a base, non-corrosive base. This non-corrosive base is added to baking the products. Also, it is used for making for cooking things faster. Tasty crisp pakoras. What will actually happen when NaHCO3 present into a dough, it is heated, it releases carbon dioxide gas which makes cake and bakery products fluffy. Products fluffy. The network, the B network you see, it's because of this carbon dioxide release on heating. Uses, it is used to make baking soda, which is a mild acid. How you will make baking soda? You will add hydrogen ion to it. It will give carbon dioxide and H2O, sodium salt of acid is produced. Carbon dioxide release will make it soft and spongy. Sodium hydrogen carbonate is also an integrate of antacids. Because it is alkaline in nature, it reduces the excess acid present in our stomach. It is also used in soda acid fire extinguishers. Instead of baking soda, we use baking powder in bakeries or in cake formation. The reason because of this is, on heating baking soda, Na2CO3 is produced. On heating baking soda, Na2CO3 is produced, which is a base, hence make cake bitter. To reduce this bitterness, what we do, we add tartaric acid in the baking soda to produce baking powder, which is which does not give the bitter taste while cooking cakes. Okay, next compound is washing washing soda. Washing soda is chemical formula for washing soda is Na2CO3 dot 10H2O, and its chemical name is sodium carbonate decahydrate. When when Na2CO3 sodium carbonate, after heating baking soda, we obtain sodium carbonate, and when you heat this sodium carbonate, when you treat this sodium carbonate with water, you will get washing soda. Into this compound you will find water of crystallization. This 10H2O, what is the significance of this 10H2O present into the sodium sodium carbonate? These 10H2O hold a very significant importance in the compound, as you can categorize the compound on the basis of these 10H2O. If Na2CO3 does not has any H2O molecule, it is a white dense powder used in glass making industries, easy to transport, commonly known as soda ash. But once it get combined with 10 molecules of water, these water of crystallization molecule make it washing soda, used for laundry purposes. Laundry purposes, uh, it softens the water, create an alkaline medium, make it suitable for washing the clothes. Okay, and there is one term here known as efflorescence. What is this? When this Na2CO3.10 H2O, washing soda, left open in atmosphere, it loses its water of 9 molecules of water of crystallization and becomes Na2CO3 dot H2O. It's also a stable monohydrate compound. It's a stable monohydrated compound, and 9H2O molecules are released into atmosphere. The significance of this 10H2O: first, it make soda ash into washing soda. Second, it helps in stability of the compound. Okay, it make more stable, it make this compound more stable, and its physical characteristic also changes, like in if you take an example of CuSO4, if CuSO4 has its water of crystallization, it give it a blue color, a very beautiful blue color, but when you heat it, it loses its 5H2O and becomes colorless powder. And physical characteristics is also defined by these water of crystallization. As washing soda components, washing soda is used in glass, soap, paper industries, manufacturing various sodium compounds like borax. It is used as cleansing agent in domestic purposes, laundry and all. It removes the hardness of वाटर. ओके, यहाँ पे आपको ये इफ्लोरेंस वाली एक्टिविटी दी गई है वाटर ऑफ क्रिस्टलाइजेशन रिमूव करने के लिए. यहाँ पर कॉपर सल्फेट के बारे में बताया गया है कि जब आप कॉपर सल्फेट को हीट करोगे तो उसके क्रिस्टल्स ब्लू कलर में फॉर्म होंगे, एंड वो क्रिस्टल्स को जब आप लेफ्ट ओपन कर दोगे तो दे विल लूज देयर 5H2O and it will turn as a colorless powder on evaporating the water of crystallization present into it. It is a what is water of crystallization? It is the fixed number of water molecules present in one formula unit of a salt, and what they do, they provide stability to the compound and sometimes give color to the compound. It crystal structure. Okay, next component is plaster of Paris. Okay, let's further move. Last component, plaster of Paris, POP. This compound is obtained when gypsum is heated at 373 Kelvin. It loses its water of crystallization, 3 by 2, 1.5 molecules of water, and becomes calcium sulfate hemihydrate, CaSO4 dot half H2O. This CaSO4 dot half H2O is known as plaster of Paris. Here the equation is given: when plaster of Paris absorb water, absorb water, it converted into hard gypsum, and when gypsum is heated, if this reaction is taken in a reverse direction, CaSO4 dot 2H2O, when it is heated at temperature 373 Kelvin, you need to mention the temperature here, it will give you CaSO4 dot half H2O plus 3 by 2 H2O molecules of water is released. This is known as your POP, or calcium sulfate hemihydrate. calcium sulfate, hemihydrate. This compound is used for making toys, materials for decoration and making smooth surfaces in the construction. Fall ceilings में भी इसी का use किया जाता है. Okay, this is all about this chapter. Let's discuss the in-text questions. First is, what is the common name of compound Ca? Bleaching powder. Next is, name the substance which on treatment with chlorine yields bleaching powder. Substance which on treatment with chlorine gives you bleaching powder. The substance is CaOH whole twice, calcium hydroxide. Name the sodium compound which is used for softening of hard water. Na2CO3 dot 10H2O. Washing soda. What will happen if a solution of sodium hydrocarbonate is heated? Sodium hydrocarbonate NaHCO3, sodium bicarbonate B. On heating, it will give you Na2CO3. Okay, hydrogen is removed. Again, write an equation to show the reaction between plaster of Paris and water. It is mentioned here. Plaster of Paris react with 1.5 molecule of water and form gypsum. We have discussed here in text questions. Okay, this in text questions are left. Why do HCl and HNO3 etc. show acidic character in an aqueous solution, while solution of compounds like alcohol, glucose do not show acidic character? This is because these two give H positive ion when added to water, whereas when they dissolve into water they do not give H positive ions. Okay, so they show acidic behavior while they do not. Next, why does an aqueous solution of an acid conduct electricity? Because of the presence of H positive ion. Third, why does dry HCl gas not change the color of litmus of paper? Because HCl will acid will show their acidic character only in presence of water. Acids show acidic character only in presence of water. Fourth question, while diluting an acid, why it is recommended that acid should be? Because it is an exothermic reaction. A lot of heat is produced. If you add water to acid, the acid will splash and cause burn. How is the concentration? Fifth question, how is the concentration of hydronium ion affected when a solution of acid is diluted? It decreases, because when you dilute it, more water is given to it and hydronium ion concentration decreases. Sixth question, how does the concentration of hydroxide ion happens when an excess base is dissolved? It increases, because more is the base, more is the OH negative ion, and hence concentration of hydroxide ion will increase. Okay, in text question on page number 3 of the chapter, I think. Okay, why should curd and sorrow substance not to be kept in brass and copper vessels? Because acid react with metal and produce salt plus water. Which gas is usually liberated when acid reacts with metal? Hydrogen gas, and you can test its presence by passing it through a soap solution and uh, keeping a fire near to it. It burns with a popping sound. Third question, metal compound A react with dilute hydrochloric acid to produce efference. The gas evolved extinguishes a burning candle. Write the balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. यहाँ पे कंपाउंड ए के बारे में आपको बताना है. देखिए, गैस इवॉल्व एक्सटिंग्विशेस द बर्निंग कैंडल, इसका मतलब गैस कौन से इवॉल्व हो रही होगी? कार्बन डाइऑक्साइड. एक प्रोडक्ट हमें लिस्टेड किया हुआ है कैल्शियम क्लोराइड, दैट इज CaCl2. सो ये कहाँ बनते हैं? ये तब बनते हैं जब एक मेटल कार्बोनेट रिएक्ट करता है एसिड के साथ और साथ में निकलता है वाटर. सो डाइल्यूट हाइड्रोक्लोरिक एसिड, तो आप लिखेंगे HCl, और सॉल्ट कैल्शियम फैमिली का है तो आप साथ में Ca2CO3 आप मेंशन करेंगे, कैल्शियम कार्बोनेट. सो दिस इज योर रिएक्शन फॉर द क्वेश्चन 3. This question, you have been provided with 3 test tube. One of them contain distilled water, the other 2 contain acidic solution and a basic solution. If you are given only red litmus paper, how will you identify the contents of each test tube? See, you have a red litmus paper, so it will retain its color in acidic solution and it will change to blue in basic. तो जिस सॉल्यूशन में वो ब्लू होगा दैट इज बेसिक. अब वो रिटेन करेगा अपने करेक्टर को न्यूट्रल के अंदर और एसिडिक सॉल्यूशन के अंदर. तो अब हम क्या करेंगे, डिस्टिल्ड वाटर को 2 सेपरेट कंटेनर्स में लेंगे और उसके अंदर एसिडिक और बेसिक को ऐड कर देंगे. 1 टेस्ट ट्यूब डिस्टिल्ड वाटर प्लस एसिड and another one is distilled water plus base. Now we again use this red litmus, this will turn blue and this will turn acid. No, this will not change its color, it retain its red color, hence we can say that this is a neutral substance. That's all about this chapter. Hope we have covered all the points. Exam is nearby. Just keep revising, keep practicing. Thank you so much. Tomorrow we'll meet with chapter number 3. Thank you. Hello students. Welcome to Momentum Masters. Today we are starting a very important chapter, metals and non-metals. This chapter is extremely important for your board exam. And in this one short session, we'll cover the complete chapter line by line. Before we begin, look around you. The fan, iron gate, copper wires, utensils, jewelry, pencil lead, even the oxygen you breathe. All of them are elements, and some of these elements are called as metal and others are called non-metals. They are called so on the basis of their difference in properties. Now there are 2 types of property. One is called physical property, which uh, considers the appearance of materials and their touch. On these basis, the materials are classified as metals and non-metals. Now, how these metals are categorized on how these metals appearance differ. So, metals appear lustrous. They have a shiny surface and this is called metallic luster. Now, next is when you cut a metal with a sharp knife, you are not able to do so because they are hard. They are hard and this hardness varies from metal to metal. Few are very hard and few are less harder. Now, next is hammering. If you hammer it, it will it can be bitten into thin shades, and this ability to get bitten in thin shades is known as malleability. Gold and silver are the most malleable metals you have. Next comes wire. The ability of metal to drawn into wire is known as ductility, and the most ductile metal is gold. There is a fact given here that 1 gram of gold can be drawn into 2 kilometer length of wires. Now you see the cooking vessels around you, they are usually made up of aluminium and copper because they are good conductor of heat, which is shown by this figure. They have they have fixed a pin into a metal wire by the help of wax. On heating the metal wire, the heat will pass to another end through the help of conduction, and this wax will melt and the pin will fall. Though this experiment shows that metals are good conductor of heat and electricity. Now best conductor are silver and copper. Hence the wiring in our houses is made up of copper because silver is costly. Lead and mercury are also good conductors of heat, but they lie below silver and copper. Next activity shows you the electric current ability. Generally, the wires in our house made up of copper is covered by rubber. This rubber this coating is done over them to prevent the shock. Last is when one metal strike the another metal or any surface, it produces a ringing sound. Hence, they are known as sonorous. Next is our non-metals. In non-metals, you have some examples like carbon, sulfur, iodine, oxygen, hydrogen. Non-metals are solid or gases except bromine, which is liquid. Similar way, metals are solid, and the exception is here is mercury. Mercury is liquid at room temperature. All other solids are all other metals are solid. Next comes is in this activity you have to collect few like carbon, coal, graphite, and you have to distinguish on the basis of their surface. Basically non-metals are non-shiny, they are non-lustrous, they are soft, not hard, they are non-malleable, and they are non-ductile and poor conductor of heat. They produce dull sounds, not ringing sound like metals. Now here some exceptions are given. जैसे कि mercury does not exist as solid at room temperature. Mercury is liquid basically at room temperature. Metals have high melting and boiling points, but gallium and cesium are the two exceptions which having a low melting point. Iodine is a non-metal but lustrous. This is exception of non-metals. Carbon being a non-metal form a hardest substance on the earth, that is diamond. Diamond is an allotrope of carbon which is having high melting point and boiling point, which make it very hard also. So exception of hardness in non-metal is diamond. Graphite, another allotrope of carbon, is a good conductor of electricity, again an exception of non-metal. Some alkali metals like lithium, sodium, potassium, they are so soft that you can cut them by the help of a knife. They also have low densities and low melting point. They are also exceptional metals in this case also. Next is activity 3.8. This activity tells you about the nature of oxide a metal and a non-metal will form. Here you have magnesium, which is a metal, and sulfur, which is a non-metal. On reacting with air or the oxygen, sulfur forms sulfur dioxide and magnesium form magnesium oxide. These magnesium oxide, when dissolved into water, they form magnesium hydroxide, which is a base. Hence, they will turn red litmus to blue. Whereas this SO2, when dissolved in water, form sulfuric acid. Form sulfuric acid, and this turns blue litmus to red. So here it is written, non-metals produce acidic oxides while metals produce basic oxides. Before moving to chemical properties of metal, let's discuss the in-text question. Give an example of metal which is a liquid at room temperature. It is mercury. Can give an example of metal which can be easily cut with a knife. This is sodium. The best conductor of heat. Metal which is the best conductor of heat is Ag. It's silver. Still we use copper in our houses because they ask best conductor. Let me rewrite it. This is gold and silver. A poor conductor of heat is lead. Next question is, explain the meaning of malleable and ductile. Ductile are which can be drawn into thin metals, which can be drawn into thin wires, and malleable is thin sheets. Elements which can be drawn into thin sheets are known as malleable, and the property of drawing an element into thin wire is known as ductile. Before moving to chemical properties of matter, let's summarize all the topics which we have studied so far into a tabular form. Appearance, metals are lustrous. Metals are lustrous, non-metals are non-lustrous, exception is iodine, which we have studied. Next, they are solid, exception mercury. They are solid gaseous, liquid is only one, that is bromine. Hardness, they are hard, exception is sodium, potassium and lithium. The alkali materials, they can be cut through knives. They are generally soft, but exception is diamond. Metals have high density as they are solid, and non-metals have low density because they are liquid, or they usually exist into gaseous states. Ductility, yes, and they are non. They are malleable and they are non. Now the next question is, which is the most malleable? It is gold and silver. And if you talk about ductility, this is also gold, silver and then copper. Copper being cheaper, used in our households. Conduction, heat conduction, they all conduct heat except lead. They do not conduct heat, but exception is graphite, allotropes, carbon. Do they form alloys? Yes, they do not form alloys. Conduction of electricity, yes, again exception lead. No, exception is graphite. Do they react with water? Yes. Do they non-metals react with water? No, they do not react with water. They need to mix with water. First they need to react with oxygen, then water, and then they form what kind of oxides? They form non-metals form acidic oxides. So they form acidic oxides after reacting with acidic oxides. Okay, and similarly they form basic oxides. So these are exception tables and the brief of all the physical properties we have studied so far. Now let's move to chemical properties of the metal. The first chemical property is reaction of metals with the air. How metals react with oxygen. In first chapter, we have studied that magnesium burn in the presence of air with the help of white dazzling flame and produce MgO. Activity 3.9 asks you to do the experiment of burning metals into the air. So from this activity, we can conclude that metal plus oxygen give us metal oxides. Example like copper on reacting with oxygen produce copper oxide. Aluminium with oxygen produce Al2O3. Again, aluminium has a valency of 3 and oxygen has a valency of 2. So the compound is Al2O3. Now, chapter 2, if you remember the reaction of copper oxide with hydrochloric acid, let me write it down for you. It is CuO plus HCl give rise to CuCl2 plus H2O. So, it is a salt, it is an acid, hence the copper oxide acts like a base. So, on this basis, we can say that the metal oxides are basic in nature. But there are some oxides like aluminium and zinc oxide which react with both acid as well as base. So, the metal oxides which react with both acids and bases are called as amphoteric oxide and they produce salt and water. This amphoteric oxide is one of the favorite topic from this chapter, and they used to ask what is amphoteric oxide, either what is amphoteric oxide or either the formation of sodium aluminate and sodium zincate. Here aluminium oxide react with acid to form salt and water. Again aluminium oxide reacting with a strong base to form again a salt, sodium aluminate plus water. Same is with zinc. If let me write it down the reaction for zinc, like NaOH plus ZNO give rise to Na2ZnO2 plus H2O. Okay, and the reaction of Na2O with HCl give rise to NaCl plus H2O, salt and water. This reaction need to be zinc hydroxide, and this is Na2O. The oxide of sodium oxide reacting with a base to produce a salt, sodium oxide reacting with a acid to produce a salt. So these two reactions are important. Now the next point is these metal oxides are insoluble in water. Few are soluble and those are known as alkalis, and these are sodium oxide and potassium. They react with water to form NaOH and KOH. Okay, further if you see all metals reaction with oxygen are not at the same rate, it is different. Like sodium and potassium, they catch fire if they are kept open, hence they are protected into kerosene. Whereas some metals like magnesium, aluminium, zinc, lead, they will develop a thin layer of oxide which act as a protective oxide layer and help them from further stop the further corrosion. Whereas iron does not react on heating, but iron fillings burn. Similarly, copper produce a black colored copper oxide. However, silver and gold do not react with oxygen even at high temperatures. Here one example is given, a short note is given about and sorry anodizing of aluminium. But before anodizing, let me explain this protective oxide layer. One more question usually asked him, that where aluminium protective, why the why the cracks in the railway track is filled with aluminium instead of iron. This is done to prevent when a huge amount of heat is provided to the crack, the rust in the presence of aluminium produce iron plus Al2O3. Now this formation of Al2O3 acts as a protective oxide layer and prevent the further corrosion of the railway track and increase the strength of the railway track. So this is one of the example, and this reaction is known as thermite reaction, and it is done to fill the railway track, the cracks in the railway track. Okay, next is anodizing. Anodizing is a electrochemical process where a thick layer of aluminium oxide is developed by keeping aluminium rod at electrode. Here it is written, it's a process of forming a thick oxide layer. This is done to prevent the further corrosion. This is done by treating aluminium with sulfuric acid. Oxygen gas is involved at anode and stick to it and form a thick protective. And why it is done? This oxide layer can be dyed easily to give aluminium an attractive finish, as well as this increases their strength also. Let me draw it for you. There's a beaker. You have kept one plate as anode, another as cathode. This is uh, connected to anode connected with the positive end and cathode connected with the negative end. This is your cathode and this is your anode. H2SO4 solution is here. On passing the electricity, this H2SO dissociate to give H positive ion and SO4 two negative ions. These SO2 4 negative ion deposit here, and H2 will move towards this side, and a positive charge will develop here and H2 gas releases. The negative charge develop here and oxide gas releases, forming a thick layer of oxygen here, and hence improving the ability, increases its corrosion resistance. Surface hardness, increases the surface hardness. And increase wear resistance. This is done for automotive parts and in aerospace components. Okay, let's move further. Here are few lines which tell that like all metals do not have the same reactivity with the oxygen, but only with reaction with the oxygen cannot define their reactivity order. So further we need to study metals reaction with the water. Here the setup stores that action of steam on a metal. Let's take it, this is a metal, glass, wood, softened water. This is a metal, this steam, this is a glass wool soaked in water, so it will produce steam on heating. Water as gaseous state G, and this gaseous state will interact with this metal and further reaction take place. Hydrogen gas is produced and that can be catched by the formation of bubbles in the water. How metals react with water? The metals react with water to form metal oxide and release hydrogen gas. On further, if the reaction is not stopped here, this metal oxide further react with water to produce metal hydroxide. Few examples are given here. When potassium reacted with water, it produced KOH, hydrogen gas, and a lot of heat is released. Same is the reaction of sodium with the water. These two substances react very fast with the water, cold water. Even sometimes they react with the atmospheric water vapors also. ठीक है, तो सोडियम रिएक्टर वेरी फास्ट वायलेंट है, एक्सोथर्मिक रिएक्शन है, एंड हाइड्रोजन गैसेस इवॉल्व, हेंस दे कैच fire. That is the reason they are kept into kerosene to prevent this reaction. Second is calcium. The calcium react with water but less violently, and but enough hydrogen to rotate it into the bucket. When calcium react with water, it forms calcium hydroxide and hydrogen gas. This hydrogen gas uh, gives fuel. So when you burn a calcium, you will see that the calcium will move, rotate over the top of the surface because of this hydrogen gas. Now magnesium, they do not react with cold water, they only react with hot water. Although the reaction with cold water happens, but it was at a very slow pace. With hot water they react and form magnesium hydroxide and hydrogen gas, and this hydrogen gas again floating due to this sticking to its surface and causes the floating of magnesium over the water surface. The same happens with calcium and magnesium. For calcium, this happens because of cold water, reaction is cold water, and in magnesium this happens when reaction react with hot water. The metals below magnesium like aluminium, iron, zinc, they react with only steam and form metallic oxide and hydrogen gas. Again, two examples, aluminium and iron reacting with steam forming aluminium oxides Al2O3 and iron reacting Fe3O4. They form oxides, whereas till magnesium they form hydroxides. And the metals below them like lead, copper, silver, gold, they do not react with water at all. Let me summarize it for you. So potassium and sodium, then comes calcium, then magnesium, and then comes your aluminium, iron and zinc, and below them is lead, silver, lead, copper, silver and gold. They do not react, no reaction with water. These three react with steam, matlab gaseous state of water. This react with hot water. This react with cold water and causes floating of the metal over the surface, and sodium and they violently react with water, hence need to store into a kerosene or paraffin wax. Okay, and one more thing, this aluminium, iron, zinc, they react and form oxide, whereas the above forms hydroxide. These all points you have to remember. These reactions with water help us in the formation of reactivity series. Next, metals reaction with acids. When metals react with acid, they produce salt and hydrogen gas. Metal with the diluted produce salt and hydrogen gas. These reactions you have already studied in the previous chapter, that is acid, base and salts. Okay. So here collect all metal samples except sodium, potassium, clean them with the sandpaper, put them into test tube with hydrochloric acid, suspend thermometer because these are exothermic reactions, bubble formation because of hydrogen gas, with which metal did you record the highest temperature and arrange them into the decreasing order of reactivity series. Okay, so these are all your magnesium, aluminium, zinc and iron in the reactivity ऑर्डर हो जाएगा. This changer is very important from board perspective. Here, hydrogen gas is not evolved when this reaction, when you take HCl and H2SO4, sulfuric acid or hydrochloric acid, the reaction will take place and hydrogen gas is produced. But being HNO3 nitric acid, being HNO3 as an acid, still there is no hydrogen production take place. Why so? Because HNO3 is a strong oxidizing agent. It oxidizes the H2 and produce water, and itself get reduced to produce NO2O and NO, nitrogen monoxide, nitrogen dioxide. But magnesium and manganese react with diluted HNO3 to produce hydrogen gas. The metals above these, मतलब कि सोडियम, पोटेशियम एंड कैल्शियम, जो तीन मेटल्स हैं वो HNO के साथ रिएक्ट करते हैं, तब हाइड्रोजन गैस फॉर्म नहीं होती. सोडियम, potassium, sodium and calcium when react with HNO3, then this HNO3 acts as oxidizing agent and produces, and no hydrogen gas is produced. No hydrogen gas is produced. Remember these point. This is one of the favorite topic to ask question in this chapter. Okay, above the mentioned above, the order of the reactivity series decreasing order is magnesium, aluminium, zinc and iron. In this case, copper, there is no bubbles seen. So temperature also remains unchanged. So we can say this shows that copper does not react with diluted HCl. Copper lies below hydrogen in the reactivity series. Now the aqua regia. As we know, the gold, platinum, silver lie below in reactivity series and they do not react with acids, water, oxygen. But aqua regia, also called as royal water, formed by the combination of concentrated hydrochloric acid and in concentrated nitric acid in a ratio 3 form, has the ability to dissolve gold and platinum. This is used to test the purity of gold. The next topic is how metals react with solutions of other metals. Let's study this. As you can see here, in one test tube, you have taken an iron nail and copper sulfate solution. In another solution, you have taken a copper wire and iron sulfate solution. So let's name it as test tube A and this is test tube B. And test tube A, where you have taken iron nail. So let's iron mixed with copper sulfate solution, it will give FeSO4 plus copper. Because iron is more reactive than copper, hence it will displace copper from the sulfate ion. Whereas in test tube B, where you have taken a copper wire in iron sulfate solution, no reaction will take place because copper is less reactive than iron. Okay, because copper is less reactive than iron. So far we have studied of the reactivity with oxygen, water and acids. Now in this chapter we have in this section we study metal A reacting with salt solution of another metal B, and if metal A is more powerful than metal B, it will displace it. This gives rise to the reactivity series. What is reactivity series? It is the list of metals arranged in the order of their decreasing activities, या decreasing uh, ability to form the compound. So topmost is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, and below hydrogen ones does not react with acid, because in acid you will have H, and they all are less reactive than hydrogen, so they can't displace hydrogen from the acid. Okay, let's start with question answer of this section. First is, why sodium kept immersed in kerosene oil? Because sodium is a reactive, highly reactive element. It react with atmospheric oxygen and moisture and cause burn. So it is immersed in kerosene oil to break its contact. Write equation for the reaction of iron with steam. So it is Fe plus H2O give rise to Fe3O4 ferric oxide plus hydrogen gas. It is not balanced. Let's balance it. On right hand side you have 2 hydrogen and this is 2, iron is 3. So let me place it 3, and oxygen ke liye it is 4 and 4. Now it is balanced. Calcium and phosphate with water. Calcium and phosphate with water is, uh, let me write it. So that this reaction is calcium plus water give rise to calcium hydroxide plus hydrogen gas. Potassium with water give rise to KOH plus hydrogen gas. On balancing, like this, and that is 2H2O. This is the balance. Okay. Next is question number 3. You samples of 4 metals A, B, C, D were taken and added to the following solution one by one. The result obtained has been tabulated as follow, and on that basis, which is the most reactive metal? As it is able to displacement reaction take place, zinc and sulfur nitrate does not. So the answer is, before answering this, let's rearrange them. If it is able to replace copper, not able to replace zinc or silver, so A will be higher affinity than copper and Ag, but less affinity than iron. So this, and in the second, and zinc also. Zinc. Next, B. B will displace iron but not zinc, so B should be placed here. So this is zinc B. And then C. C is somewhat here. So this is D. Okay, and C is least reactive. So this C is in background. So which is the most reactive? So answer is B is the most reactive. Second question, what would you observe if B is added to the solution of copper sulfate? As B is more reactive, it displaces. यहाँ पे B will displace, blue color will fade. blue color will fade away. Okay. Next, arrange metal A, B, C, D in their decreasing. B is the highest reactive, then A, then D, and then C. Okay. Next, reddish is in. You can add one more point. Key copper deposit on the road, and this gives you reddish brown color. So which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction with iron rates with this. Hydrogen gas is produced and the reaction is Fe plus H2SO4 give rise to FeSO4 plus water. Last, what would you observe when zinc is added to the solution of iron sulfate? Reaction, write the reaction that take place. So this, when zinc is added, so zinc plus FeSO4 give rise to ZnSO4, zinc sulfate, and Fe. Green color, this is pale green color. This green color disappears and a grayish black deposits of iron is obtained. Okay, so this is your reaction. Now the next topic is how do metals and non-metals react. In this section, we're going to study about the valence shell of different elements, on the basis of which we got categorize them as metals and non-metals, and this electronic configuration of their is responsible for their reaction, that how they react. Okay, so in class 9 we have studied four shells KLMN. It is shell 1, 2, 3 and 4. The rule through which we fill the electron is 2n square, where n is 1 for K and 2 for N. Apart from that, there is the octet rule which states that maximum electron in valence shell is 8. Maximum electron in valence shell is 8. So we have to fill them. Now these are noble gases which do not react at all because their octet is completely filled. Whereas in metals, as you can see, sodium 1, 2 and 3. 1, 2. So they are having less number of electrons. So they are electron givers. And by giving electron they form positive ions, whereas in non-metals it is 5, 6, 7, so they are electron receivers and hence they form negative ion. So when NaCl reaction take place, when you dissolve NaOH in water, the sodium into it dissociate to give Na positive ion and one electron is released. Now this electron combined with the chlorine present into the water and form chlorine ion. Now one ion is negative, another is positive. Due to force of attraction, they form a compound known as sodium chloride, and the bond formed in this type of reaction is known as ionic bond. Ionic bond are those type of chemical bond where actual exchange of electrons take place between a metal and a non-metal. There are few more examples. The formation of MgCl2. So Mg, it has two valence electrons, so it will release two electrons, and these two electrons are taken up by the chlorine to form chlorine negative ion, and when two chlorine negative ion merge with magnesium, it forms a magnesium chloride compound. Now what are the properties of these ionic compounds? There are compounds like sodium chloride, potassium iodide, barium chloride. These all salts are formed due to ionic bonds. So from activity 3.3, what points we can infer is their physical state. Ionic compounds are solid in nature because they have a strong force of attraction between their ions. Melting and boil, hence they are also brittle and break into pieces when pressure is applied. Second property is melting boiling points. They have a high melting boiling point, uh, hence it requires a large amount of energy to break these bonds. Solubility, they are highly soluble in water and insoluble in solvents like kerosene and petrol. Basically less soluble in oily solvents and soluble in water. Next point is conduction of electricity. As they are soluble in water, hence when you dissolve them into water, they contain iron, and these ions help into the passage of electricity. Therefore, they are good conductor of electricity in molten state. But if you take them into solid state, then these ions will not dissociate and it will not allow electricity to pass. Okay, let's move to question. Question is write the electron dot structure for sodium, oxygen and magnesium. This is an important one. So sodium, atomic number 11 and configuration 281. So structure is Na, 2 electrons in first shell, then in second shell you will have 8 electrons, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 and 8. In last shell you will have just 1. Next is for oxygen. Oxygen, atomic number 8, so it is 2 and 6. Oxygen, first shell 2 electrons and second shell 1, 2, 3, 4, 5, 6. Has the ability to get 2 more electrons to form oxygen, 2 negative ion. Magnesium, Mg again, it also 12. So this is 2, 8 and 2. You can draw the structure. Show the formation of Na2O. Na2O, because oxygen has 6 electrons in its last orbit, it combines with 2 Na, as Na has 1 valence electron in their shell, and on the combination of these two they form Na2 positive with oxygen negative. Then in a similar way you can form for Mg valence electron 2 and oxygen valence electron 6. Mg2 positive and oxygen 2 negative. Okay, why do ionic compounds have high melting point? Because they are solid, high force of attraction between the ions, and hence you can say they have a strong bond. This The next topic is occurrence of metals. Now, there are lots of metal which occur into earth crust, like sodium chloride, magnesium chloride into seawater, and a few other minerals in the crust. So, elements and compounds. The first definition: the elements and compounds which occur naturally in earth crust are called minerals. And out of these minerals, a very high percentage of particular metal into one particular mineral, and that metal can be extracted profitably from it. These are called ores. So all the elements which occur in earth crust are called minerals, and out of those minerals which can be extracted profitably are called ores. Now we will study extraction of metal. Extraction of metal depend on where metal lies in the reactivity series. If the metal lies below in reactivity series, then they are least reactive, because of which they can occur in free state in the earth crust. Like gold, silver, platinum, copper, they found in free state. But copper and silver, they lie a little above, hence sometimes they will combine with the oxygen and form sulfide or oxide air, ores also, which are further extracted by the reduction of the oxide ores. Okay. Uh, then metals which lie top of the activity series are like uh, potassium, sodium, magnesium, aluminium. They are so reactive that they never found in nature in the free state. They need to be extracted by the help of electrolysis. Whereas some middle level metals which are moderately reactive, they are found either as oxide, sulfide or carbonate ores, which can be extracted by the help of calcination or roasting. This brief flow chart shows how you can extract a metal from its ore. The first high reactivity ones, they are need to be electrolyzed to produce pure metal. Example of them are potassium, calcium, sodium, magnesium. Okay, then metals which lie in medium reactivity series like zinc, iron, lead and aluminum, etc. With these metals are exist into earth crust as carbonate ores or sulfide ores, S and CO3 ores. Now the carbonate ores are made into oxide by the help of calcination. Calcination is heating in absence of oxygen, whereas sulfide ores are done roasting, which means heating in presence of oxygen. In both the cases, they produce oxides of the metal which are further reduced to metals by the help of carbon, but the metals which lie above in reactivity series, they have more affinity with oxygen compared to carbon, hence they cannot be reduced by the help of carbon. Metals which lie very below in reactivity series like copper and silver, sometimes they exist as sulfide ores and they can be extracted by the help of roasting. Now the next is enrichment of ores. What is enrichment and why we need to do the enrichment? Ores mined from the earth and they have a large amount of soil and sand. This soil and sand present into the ores are known as gangue, and this gangue is need to be removed before extraction of metals. So the process used for removing the gangue from the ores are based on the based on the differences between the physical and chemical properties of the gangue and ore. On the basis of their difference in properties, they need to be removed first before extraction. Now the next step is extracting the metal. First we'll discuss about metals which lie low in the activity series like mercury, silver, copper. They usually they are very less reactive, hence they exist in nature in the form of oxides. Here an example of mercury ore is discussed. Mercury sulfide ore known as cinnabar is first heated in the presence of oxygen, hence this step is known as roasting. On roasting, it produces metal oxide. This metal oxide is further heated to produce pure metal. In a similar way, copper, which exists again as sulfide ore, is first roasted and then it was reduced by the help of ore itself to produce the pure copper metal, and parallel to this sulfur dioxide gas is produced. Now let's talk about metals which lie middle in the activity series like zinc, iron, manganese. Okay, so these metals has high affinity to react as they lie above in the reactivity series, hence they are occurring into the sulfide and carbonate ores. So roasting, again zinc ore known as treated with oxygen to produce zinc oxide, whereas zinc carbonate ore is heated to produce zinc oxide. This zinc oxide is reduced to zinc by the help of carbon. Some definitions are mentioned here, like the sulfide ores are converted into oxide by heating strongly in the presence of excess air, and the process is known as roasting. Whereas the carbonate ores are changed into oxide by heating strongly in limited air or no oxygen. It is called calcination. Then metal oxide obtained after calcination or roasting is treated with a suitable reducing agent such as carbon to produce metallic zinc. But some metals which lie above zinc are difficult to reduce by the help of coke. Of coke. Examples of such is like manganese or iron. So they need to be reduced by the help of sodium, calcium and aluminium. They act as reducing agent for the reduction of these oxides. Here is an example. Manganese oxide is reduced by the help of aluminium to produce manganese and aluminium oxide on a lot of heat. So this heat means they are highly exothermic. Again, iron oxide is treated with aluminium to produce iron and aluminium oxide and a lot of heat. This reaction is known as thermite reaction. Next is extracting metals, the top which lie in the top of activity series. Metals which are high up in the reactivity series are very reactive, like sodium, magnesium, calcium. They have a more affinity towards oxygen than carbon, hence they cannot be reduced. To reduce them, we have to done electrolytic reduction of their chlorides, molten chlorides. Then you take NaCl into molten form, electricity is passed through it, and This is your molten NaCl. On passing electricity current through it, the NaCl dissociate into Na positive and Cl negative ions. These Na positives get deposited to the cathode, whereas these chlorine ions deposited on anode. Hence, chlorine gas is produced at the anode. Here it is mentioned at cathode, Na combined with electrons to produce Na pure metal, whereas at anode chlorine combines with chlorine loses electron to produce chlorine of gas, which is taken away. Similarly, aluminium is also reduced by the help of electrolytic reduction. Now next topic is refining of metals. The metals which we obtained after reduction are not pure. They have many impurities, and they are purified by the help of electrolytic refining. It is nothing. Electrolytic refining is a electrochemical process it's a chemical it is an electrochemical process it is an electrochemical process used to purify the crude metal by the help of current. The impure metal act as anode, and when current passes, the positive ion of metal move to cathode, where a pure thin strip of metal is obtained. Okay, here it is shown that electrolytic refining of copper, where a solution of acidified copper sulfate is taken. Anode is made up of impure copper, where cathode is a strip of pure copper. On passing the current, एनोड से आपके कॉपर टू पॉजिटिव आयन मूव कर रहे हैं टुवर्ड्स द कैथोड, वेयर दे गेट डिपॉजिटेड. Metals like copper, zinc, tin, nickel, gold, etc. are refined by electrolytic refining. Again, impure metal anode, pure strip at cathode. A solution of the metal is used as an electrolyte. जो मेटल आपको प्योरीफाई करना है उसी का सॉल्यूशन आप एज अ मेटल सॉल्ट यहाँ पे लेंगे. apparatus आपको दिखाया है साइड में. on passing the current through this, the pure metal from the anode dissolve into the electrolyte, and equivalent amount of pure metal is obtained from the at the cathode, and the impurities, the soluble impurities go into the solution, and they settle bottom of the anode, hence known as anode mud. वो bottom of mud में store हो जाएंगे, इसलिए उसको anode mud कहेंगे. Now questions. What is mineral? Minerals are metals in earth crust. Okay. Next is your ore. What are ore? Ore, minerals through which metal can be extracted profitably. Uh, Gangue, sand, soil, basically impurities present in the ore. Name two metals which are found in nature in the free state. Those are gold and platinum. What chemical processes is obtained for obtaining a metal from its oxide? Uh, it need to be reduced. Last topic, corrosion. This topic we have already studied in chapter 1 also, but here we are going to study the corrosion of other metals except iron. So silver articles become black after some time because they are exposed to air, and the sulfur in the air react with them to develop a coating of sulfur sulfide which is black in color. Now, copper reacts with carbon dioxide in the air and slowly loses its shine and gets a green coat. So, green coating of copper is because of its reaction with carbon dioxide. Again, iron, when exposed to moist air, a brown flaky substance is formed that is called rust, जिसे हम rust यहाँ पर कहेंगे. Okay. Now, activity 3.14. This activity shows that iron requires both water and oxygen for rusting. In test tube A, there is both water as well as air. In test tube B, the water is boiled first to remove the air, and a thin oil layer is uh, put it over this water to prevent the entry of new air. Hence, no rusting will take place in this test tube. In the third test tube, they have used anhydrous calcium chloride which absorb all moisture, hence only dry air is present. Still no rusting will take place in this test tube. So this activity shows both are required for the corrosion of iron nickel. Now what we can do to prevent the corrosion? Rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating or anodizing or making alloys. Galvanization is a method for protecting steel and iron by the help of developing a thin layer of zinc through electroplating. Electroplating of iron by zinc is known as galvanization. Okay, the galvanized iron is protected against rust even if the zinc coating is broken, because it will develop a oxide layer which act as a preventive measure for the iron to get rust. Alloying is another one method to prevent. Iron is most widely used metal, but in its pure state, it is very soft and stretches easily when heated. But if it is mixed with a small amount of carbon, it becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust also. When iron is mixed with some other substances, it property changes. In fact, the properties of a metal can be changed if it is mixed with some other substances. The other substances can be metal and a non-metal. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal, and it is first it is done to do to avoid the corrosion, and the portion of each should be in definite proportion. They are first heated and then dissolved and then cooled down at room temperature to produce alloys. Now here's an example of pure gold, the 24 karat gold. It is very soft, unable to make jewelry by that much soft. So to make jewelries, it was again alloyed by the help of silver or copper, and ornaments is produced. This type of gold is known as 22 carats because it has 22 parts of pure gold and 2 parts of either copper or silver. So 2 by 24 ratio, that is 1/12 is impurity and 11 by 12 is pure gold. Metals like mercury, uh, when they are mixed with another metal, they form amalgams. Okay, the electrical conductivity and melting point of an alloy is less than the pure metal. तो electrical conductivity and melting point आपकी reduce हो जाएगी. Brass, it's an alloy of copper and zinc. Bronze, it's an alloy of copper and tin, and they are not good conductors of electricity, whereas copper is a good conductor of electricity. Similarly, there is one more alloy, solder. Solder is an alloy of lead and tin and has a very low melting point and used as welding electric wires together. It is used as soldering. The process is known as soldering. One more example of electrolytic refining is from ancient India is the iron pillar near Qutub Minar in Delhi. It was an old 1600 years ago. uh, they uh, they had developed a process which prevented iron from the rusting. For its quality of rust resistance, it has been examined by the scientists from all parts of the world, and the iron pillar is 8 meter long and weighs 6,000 kg, and there is no rust over this because a process is because it has developed the oxide layer over it. Now questions from this section. Metallic oxides of zinc, magnesium and copper when heated with the following metals. Basically displacement reaction will take place here. Now first, zinc oxide with zinc, no reaction. Zinc oxide with magnesium, magnesium will displace zinc. Copper oxide, no reaction because zinc is more reactive than copper. Next is magnesium oxide. Magnesium oxide with zinc, no. Magnesium with magnesium, no. Magnesium with copper is also no, because magnesium is the most reactive among all. The last is copper oxide with zinc. Here zinc will replace the copper, and copper oxide with magnesium, again magnesium will replace the copper, and in last no reaction will take place. Which metals do not corrode easily? Metals like gold, platinum or silver does not corrode easily. What are alloys? These are homogeneous mixtures. Mixtures of two or more metals or non-metals, which are made to improve their properties. That's all about this chapter. We'll meet again for the next chapter of class 10th chemistry, that is carbon and its compound. All the best. Thank you. Hello and welcome to Momentum Masters. Before we begin, take a moment to observe the things around you. The food you eat, the clothes you wear, The medicines you take, the fuel you use, plastics, paper, wood, medicines, LPG, all of these have one common element, and that common element is known as carbon. Now an important question arises. When there are more than 100 elements in the periodic table, then why does carbon alone form such a large amount of compounds? Let's dive into the chapter to understand this. So let's begin our journey into the world of carbon and its compound. Carbon is present everywhere in the life, from living organisms to non-living things like food, clothes, medicines, etc. This shows the importance of carbon in our life and the need to study it. Interestingly, the amount of carbon available in nature is very small. Only 0.02% of carbon is present in earth crust, whereas only 0.03% of carbon dioxide is present in atmosphere. Yet, even with such small amount of carbon, it forms huge number of useful compounds. The reason lies behind bonding of carbon. Carbon forms covalent compounds which have low melting and boiling points. They are poor conductors and they do not form ions when they dissolve into water. The forces between their molecules are weak, hence their bonding is not ionic. And if their bonding is not ionic, what is how they form, how they bond? So the reason lies in their electronic configuration. Carbon has atomic number 6, hence its electronic configuration becomes 2 and 4. The carbon has 4 valence electrons and it needs 4 more electrons to complete its octet. If carbon tries to gain 4 electrons and form C4 negative ion, it becomes difficult for the nucleus to hold 10 electrons and it becomes unstable. The compound becomes unstable. Whereas if it tries to lose 4 electron and form C4 positive cation, in that form it requires a large amount of energy for removing these 4 electrons. So gaining and losing is not feasible in case of carbon. So how carbon solve this problem? Carbon solve this problem by sharing the electrons present in its outermost shell with other carbon atom or hydrogen, oxygen, nitrogen and many other, and form a covalent compound or covalent bond. The shared electron help both the atoms to achieve a stable noble gas configuration. Let's understand this covalent bond by the help of hydrogen atom, a hydrogen molecule. When the hydrogen has one uh, electron in its outermost shell, similarly another hydrogen atom with one electron in its outermost shell shared their electrons and combined together to form hydrogen molecule. Here this single bond between them is known as covalent bond or the first type of covalent bond, when one pair of electron is shared. When similarly oxygen share 4 such electrons or 2 pairs, it forms oxygen gas molecule and it is known as double bond. When and nitrogen as nitrogen has atomic number 7. So electronic configuration 2 5. It requires 3 more electrons to achieve a stable noble gas configuration. For that it shares 3 pairs with another nitrogen molecule and form a triple bond. Oxygen, atomic number 8, electronic configuration 2 6. It requires 2 more, so 2 bond sharing, and oxygen double bond. Hydrogen single bond. Now further, let's study this the same in the case of your carbon compounds. The first element, methane, a constituent of biogas and CNG. Carbon has 4 valence electrons represented by 4 cross in the figure, where hydrogen have 1 valence electron in its outermost shell, and when it combined with another one, it completed its octet. Second hydrogen and third hydrogen, similarly fourth hydrogen. All 4 hydrogens have completed their octet. When you look into carbon, it also shares the 4 electrons or 4 different hydrogen atoms and complete its octet. This leads to the formation of methane, where 4 single covalent bonds occur. All atoms have their valency, completed their valency, and the molecule is stable. These covalent compounds have strong bond within their molecule and hence weak intermolecular forces, because of which they have a low melting and boiling points, and they are poor conductor of electricity but have stable configuration. This is the basic understanding of how carbon form compounds. Now we will move ahead to see what makes carbon a truly versatile element. Before moving ahead, let us understand allotropes of carbon. Before we study the versatile nature of carbon, it is important to know that carbon exists in different forms. These different forms of same element are known as allotropes. Allotropes have different physical forms of the same element which have different physical properties but same chemical properties, because they all have same valence electrons, only their structure is different. Carbon shows mainly 3 allotropes: diamond, graphite and fullerene. Diamond. In diamond, each atom is bounded by 4 other carbon atoms and form a strong 3D structure. Hence, diamond becomes hardest natural substance and has very high melting point. Because no electron is free, hence it does not conduct electricity. Whereas in graphite, each carbon atom is bounded by 3 other carbon atoms, forming a layer of hexagonal ring. These layers can slide over each other, hence graphite is soft and slippery. As 1 electron is free in graphite, hence it conducts electricity. Last but not least is fullerene. It is also known as C60, where carbon atoms are arranged in a shape similar to football. In one fullerene, there are 12 pentagons and 20 hexagons. So even though diamond, graphite, fullerene are made up of same element, carbon, their structures are different and hence their physical properties are different. This shows how the structure of carbon bonding changes the properties of the substance. Now let's discuss the in-text questions. What would be the electron dot structure of carbon dioxide? As carbon has 4 valence electron and each oxygen has 6 valence electrons. Hence, carbon shares 2 pairs of electron with each oxygen atom and hence forming double bond with oxygen. For dot structure, it should be represented like cross for carbon atoms and dot for oxygen. This is electron dot structure. Next is, what would be the electron dot structure of molecule sulfur acid? Sulfur has 6 valence electron. So each sulfur needs 2 more electron to complete its octet. So 8 sulfur atoms together form a ring structure in an octagon shape where 2 single covalent bonds is made by one sulfur with the neighboring sulfur. The result is a cyclic S8 ring. 1, 2, 3, 4, 5, 6, 7 and 8. Here each vertex represent one carbon atom. So this is cyclic S8 ring. Now let's move ahead to understand the versatile nature of carbon, which explains why carbon forms millions of compounds. The number of carbon atoms known today is in millions, which is much more than the compounds formed by other elements present. This versatile nature of carbon is because of two factors: catenation and tetravalency. Catenation is the ability of carbon to form bond with other atoms of carbon, which give rise to long chains, branched chains and ring structures. Also, carbon atom can be connected through multiple bonds: single, double bond and triple bond. The carbon-carbon bond is very strong and stable, which allows the formation of large number of molecules. Compounds having single bond are known as saturated compounds, whereas compounds having double or triple bond are known as unsaturated compounds. Next is no other element exhibit this catenation property. Silicon also form compounds with hydrogen up to 7 and 8 atoms only. The carbon-carbon is strong bond, hence it is more stable and it can be joined to large number of compounds. Next is tetravalency. Carbon has valency of 4. This means carbon can form bonds with 4 other carbon atoms or atoms of hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. These bonds are strong covalent bonds which make carbon compounds stable. One more reason for strong bonding is the small size of carbon atom, which allow the nucleus to hold the share electrons firmly. Hence, we can conclude that because of catenation and tetravalency, carbon forms a vast variety of stable compounds. This is why carbon is called versatile element. The most of the carbon compounds are known as organic compounds. Earlier it was believed that organic compounds can be obtained only through living organisms, through a vital force. But in 1828, Wooler prepares urea from ammonium cyanate, which is an inorganic substance. Hence, compounds that contain carbon, usually along with hydrogen, oxygen, nitrogen, sulfur, halogens, etc., are known as organic compound. Example: methane, ethanol, glucose, plastics, fuels, medicine. These all are organic compounds. However, some compounds do not consider organic in spite of the presence of carbon into them. Such are carbon monoxide, carbon dioxide, carbonates, hydrogen carbonates, and carbides. These are classified as inorganic compounds. But why are these carbon compounds considered inorganic? Because their nature is similar to inorganic compounds. Also, they lack CH bond, which is common in organic compounds. And they also not have long carbon chain, which make them inorganic. Now, let us understand an important classification of carbon compounds based on the type of bonds present present between the carbon atom. That classification is saturated and unsaturated carbon compounds. Saturated carbon compounds are those carbon compounds which has single carbon-carbon bond. Here, each carbon is connected by single covalent bonds. The valency of carbon is completely satisfied by single bonds. These compounds are generally less reactive. And they are also known as alkanes. Few examples are shown here. Whereas methane, ethane, propane are example of alkanes because the carbon chain hold the maximum possible hydrogen atoms, and these compounds are called saturated. But unsaturated hydrocarbons are those in which there is at least one double or triple bond is present. Double bond is known as alkene, whereas the presence of triple bond make them alkynes. Now these alkenes and alkynes are more reactive than saturated carbon compounds because double triple bonds are weaker and can easily break during chemical reaction, which made them the more reactive compounds comparing to saturated carbon compounds. The table 4.2 gives you some formula and structure for saturated compounds like methane, ethane, propane, butane, pentane and hexane. These are the members of alkane family, which has maximum number of hydrogen atoms. Till now, we have seen that carbon can form long chains and branched chains. But you will be amazed to know that carbon atoms can also join together to form closed structures known as ring compounds. One such common ring compound is benzene. The benzene has 6 carbon atoms which form a ring where each carbon is bonded to one hydrogen atom, and the structure contains alternating double bond of carbon. The closed loop make it very stable. Benzene chemical formula C6H6 are widely used in many organic substances like medicines, dyes, plastics, perfumes. Uh, the page shows you some another possible ring structures, a a cyclohexane where 6 carbons have single bond and further attached to 2 hydrogen atoms each, and benzene. Now let's move further and understand about homologous series. A homologous series is a group of organic compounds which have same functional group, similar chemical properties, and show a gradual change in physical properties. Each successive member differ by CH2 group. For example, methane and ethane the difference is CH2. Similar, further propane, again the difference is CH2. Each compound differs by CH2 in its series. This series have same journal formula and functional group and shows similar chemical properties and change in physical properties like melting and boiling point. The journal formula for for a homologous series is CnH2n for alkanes. Difference of 14 atomic mass units, CH2 12 carbon plus 2 hydrogen, basically 14 AMU change in corresponding parts of homologous series change its physical properties slightly. Now the journal formula for alkane, alkenes and alkynes. For alkanes, one is CH4. Now next is let's write CH2n. It is for 2n plus 2. This is for alkanes. For alkenes, it is CnH2n. For alkynes, it is CnH2n minus 2. Next is functional groups. Figure table 4.3 shows some functional groups in carbon compounds. The atoms and groups of atoms that replace hydrogen and give specific property are called functional groups. The functional group determine the chemical properties of a compound and the type of reaction it will undergo. Even if the carbon chain length change, compounds with same functional group show similar chemical properties. Few functional groups listed here are alcohol, aldehyde, ketone and carboxylic acid. Remember the formula of their functional group. CBSE used to ask one question from this particular table. Apart from these functional groups, there are a class of haloalkanes which are added as prefix into the compound name, and your haloalkanes are chlorine, bromine and iodine. Let's move further and start with the naming. How carbon compounds are named. The system of naming is called nomenclature. To name an organic compound, you must know the number of carbon atoms in the compound or in the longest chain. Second, in case of functional group, which functional group is present, its name is either added either in prefix or suffix. Next is what type of bond is present into the compound. If it is single bond, then ane, double bond ene and triple bond ine is added into the name. Let's understand with it, this with the table. This table shows root carbon atoms present in a carbon compound. If one carbon is present, then meth is used. For 2, eth, for 3, prop, for 4, it's but, and for 5, it is pent, 6, hex, 7, heptane, 8, oct, 9, non, and 10 is dec. For single bond, it's ane, double ine, and triple YNE. Functional group. OH for alcohol, the suffix is OL. For COOH, carboxylic acid, oic acid is added. CHOAL, aldehyde group. CO, ketone, on is added. Ketone is always found in the middle of chain, whereas carboxylic acid and aldehyde is found in the end of chain. Haloalkanes like prefix chloro, bromo or ido is added. Alcohol, aldehyde, ketone, carboxylic, alkenes and alkynes. Propine, propene, carboxylic acid, propanoic acid, CO, propanol, CHO, propanol, OH, propanol, Br, bromopropane, Cl, chloropropane. Let's discuss the in-text question in this page. How many structural isomers can you draw for pentane? Pentane has 5 carbon atoms and you can draw 3 isomers for it. Before drawing 3 isomers, you must know what is an isomer. Isomerism is the phenomena in which more than one compound has same chemical formula but different chemical structure, and thus the different chemical compounds obtained are known as isomers. These isomers have different chemical properties. Here isomers of pentane is drawn. The compound is C5H12 pentane. When it is drawn into a long chain, its structure look like this. When a branch is drawn, it becomes isopentane and its chemical name become 2-methyl butane because now it has only 4 carbon atoms in its longest chain. 1 carbon atom become its branch. So 2-methyl butane. And when two branches are created, it becomes neopentane. Now there is only 3 carbon atoms, whatever way you take the chain, like horizontally or vertically, 1 2 3, either this way or either this way. In both the ways, the number of carbon atom, maximum number of carbon atom in a compound is 3. The chemical formula becomes 2,2-dimethyl propane. So these are 3 isomers of pentane. Next question is, what are the 2 properties of carbon which led to huge number of carbon compounds? It is tetravalency and catenation, ability to form long and branched chains. What will be the formula and electron dot structure of cyclopentane? Let's draw its electron dot structure first. One hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10. So H10. Now carbon. One carbon, 2 carbon, 3, 4 and 5. So C5. Formula is C5 H10, and this is its electron dot structure. Next is, draw the structures for the following compounds. First is ethanoic acid. It's CH2. Sorry. Let's first draw oic group, that is COOH. Now this carbon has one another carbon which is further connected to 3 hydrogens. So formula is CH3COOH. Bromopentane. It's pentane 1, 2, 3, 4, 5. Bromine group is attached. Now remaining with H. So formula becomes CH3, CH2, CH2, CH2 bromine. Sorry, 4U. Let me add one more. CH2 bromine. Next is butanol. So 4 carbon, 1, 2, 3, 4. Double bond on 1. Now CH3, CH2 and CH3. So it is butanol. Hexanol, 6 carbons, 1, 2, 3, 4, 5, 6. Now OH. So this is aldehyde group, remaining CH2, 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 CH2 and CH3. So this is hexanal. Are structural isomers possible from bromopentane? Yes. There are lots of structural isomers of bromopentane. You can replace this bromine group from first carbon to any other carbon to achieve its bromo isomers. Question number 5th, naming the compounds. This has 2 carbon, hence eth, single bond, hence ane, and bromo group makes it bromoethane. This has aldehyde group and 1 carbon, so it is methanol. Next, it has 1, 2, 3, 4, 5, 6 carbons and hex. The presence of triple bond makes it hexene. Hexene. That's all about the questions. Let's move further with the next part of the chapter, that is chemical properties of the carbon compounds. Since most of the fuels we use are carbon compounds, hence we need to study combustion. Carbon and its compound burn in oxygen to produce carbon dioxide, heat and light. Here are few examples when carbon burns with oxygen: methane, or you can say natural gas burning, biogas also. Next is ethanol in the presence of oxygen, give rise to carbon dioxide, water, heat and light. Carbon compounds burned with flame. Saturated carbons, saturated hydrocarbons have clean blue flame, whereas unsaturated hydrocarbons burn with yellow sooty flame, which indicates incomplete combustion in presence of insufficient oxygen and a lot of black smoke. The gas and kerosene oil used in our house has many inlets for the air, so sufficient oxygen is present, leads to clean blue flame. But if few of air holes are blocked, then the cooking vessel becomes blackened due to the production of carbon monoxide and soot, which is nothing, just carbon. Now, do you know why do substance burn with or without flame? The gaseous substance burn with flame, whereas solid do not produce flame. Also, the flame color depends on the characteristics of burning. Like yellow color of candle flame indicate incomplete combustion, whereas the blue flame in LPG indicate complete combustion. Next is formation of coal and petroleum. Coal formed due to the decomposition of dead remains of flora present on the earth millions of years ago under high pressure of earth causes it to form coal, whereas oil and gases are the remains of plant aquatic plants and animals. They get deposited in between the impervious rocks and can be taken out further. These are called fossil fuels because they are formed due to dead remains, which are known as fossils. Next topic is oxidation reaction. Carbon compounds can easily oxidized on combustion. They just require oxidizing agents for these reactions to take place. Oxidizing agents are nothing which provide oxygen for the reaction to take place. Like alcohols, alcohols are oxidized to give carboxylic acid, and one such example is given here. When ethanol is oxidized to form ethanoic acid, and the oxidizing agent used here are either KMnO4, potassium permanganate in alkaline medium, and K2Cr2O7, potassium dichromate in acidified form. These substances add oxygen or remove hydrogen from the compound and produce ethanoic acid. Next is addition reaction. When unsaturated hydrocarbons uh, are formed by the addition of hydrogen, when hydrogen is added into unsaturated hydrocarbons in the presence of catalysts like palladium, nickel, platinum, this type of reaction is known as hydrogenation. Given here, when a unsaturated hydrocarbon hydrogenated and it becomes saturated hydrocarbons. These hydrogenation of the industrial application of this reaction is production of vanaspati ghee. Here we know that vegetable oils are healthy, where because animal fat contains saturated fatty acid which are harmful for the oil health. Hence we should cook into oils, not in unsaturated fatty acids. Next is your substitution reaction. Saturated hydrocarbons are fairly unreactive and inert in the presence because they have a strong carbon-carbon bond. But they undergo substitution in the presence of sunlight. Chlorine can be added to them and it is a very fast reaction. When methane is treated with chlorine in presence of sunlight, it produced CH3Cl, that is chloromethane. Here, one hydrogen atom is replaced by chlorine. Many such reactions can take place, like CH4 on adding to Cl2 give rise to CH3Cl plus HCl. Again CH3Cl passes from chlorine gas, it gives CH2Cl2 plus HCl. If this reaction is further comes into contact with more chlorine gas, it dissociates to form CHCl3 plus HCl. And the last, CHCl3, when contact with more chlorine, it forms CCl3 plus HCl. This is known as tetrafluoride. Next, the in-text questions. Why is conversion of ethanol to ethanoic acid called a oxidation reaction? Because in this reaction, oxygen is added and hydrogen is removed. A mixture of, second is a mixture of oxygen and ethane is burnt for welding, and such welding is known as acetylene welding or oxyacetylene flame is produced during this welding. Can you tell why a mixture of ethene and air is not used? Because insufficient heat is produced. Due to incomplete combustion of ethane in the presence of air, and carbon monoxide is produced instead of carbon dioxide. It causes air pollution as well as it reduces the temperature and the metal will not melt during welding. Next topic is carbon compounds. Two commercial important compounds are ethanol and ethanoic acid. Ethanol. Ethanol is, the chemical formula for ethanol is C2H5OH. It is liquid in room temperature. It is liquid at room temperature, a colorless liquid which is a very good solvent used in medicines, perfumes, and cough syrups. And many tonics. As it is soluble in water and hence can be used as fuel and a main component of alcoholic drinks. Excess consumption of alcohol can lead to many health problems. Now the chemical properties of ethanol. When ethanol reacts with sodium, it produces sodium ethoxide. Remember, in sodium ethoxide, there is only one oxygen in between. Hydrogen gas is produced during this reaction. It is quite similar to the reactions of metals. Next, reaction with unsaturated hydrocarbons. When alcohol is heated in the presence of hot concentrated H2SO4 at 443 Kelvin, it results into an unsaturated hydrocarbon ethene by the production of water. As water is removed during this process, hence sulfuric acid is act as dehydrating agent and it removes the water from the ethanol. This reaction is also known as dehydration reaction. Next is, do we know? Here, how alcohol affect a living being. The consumption of alcohol basically slows down the metabolic process and it depresses the nervous system, affecting our nerves and result into lack of coordination between the our body, a mental confusion, drowsiness. Hence, the sense of judgment reduces, due to which muscular coordination seriously impaired. Unlike ethanol, if you drink the first member of the alcohol family, that is methanol. Even the small quantity of methanol can cause death, because methanol oxidizes to form methanol, because of which the cells coagulates the protoplasm and it becomes hardened. Like when you boil an egg, it becomes hardened. The same effect methanol shows on our cell, on our body cells. Hence, to prevent the misuse of ethanol, which is an important industrial solvent, some methanol is added to it. This addition of methanol is known as denatured alcohol. This denatured alcohol saves the ethanol misuses. Let's move further. Alcohol is also used as fuel. Many countries use alcohol as an additive in petrol, because the alcohol also shows combustion reaction and produces carbon dioxide and water in presence of sufficient air and can act as a cleaner fuel. Next compound is ethanoic acid. Ethanoic acid, commonly known as acetic acid, is the second member of carboxylic acid group. The 5 to 8% solution of acetic acid with water is known as vinegar, which is a common integrant into kitchens. It helps us to preserve pickles. The melting point of pure ethanoic acid is 290 Kelvin, close to room temperature. Hence, it freezes during winter and called as glacial acetic acid. These organic compounds has acidic nature and are called weak acids. The first reaction of ethanoic acid with alcohol is known as esterification reaction. When ethanoic acid reacts with ethanol in the presence of acid, it produces a sweet smelling substance known as ester along with water. On treating this ester with sodium hydroxide, it converted back to alcohol and sodium salt of carboxylic acid, which helps in the preparation of soap, and such reaction is known as sponification. So what are soaps? Soaps are the sodium potassium salts of long carboxylic acid. This is an important definition. Soaps are sodium potassium salts of long chain carboxylic acid. Let's study further the sponification reaction. It is the on heating ester in presence of sodium hydroxide gives soap, a component of soap. Now the reaction with the base, how it reacts with base. When alcohol treated with NaOH, when ethanoic acid treated with NaOH, it produces sodium ethonate and water. As there are two oxygen, it is sodium ethonate, not sodium ethoxide. Sodium ethoxide is produced when alcohol is treated with Na. But when carboxylic acid is treated with NaOH, it produces ethanoate, sodium ethanoate. How does ethanoic acid react with carbonates and hydrogen carbonates? Let's take one example. Ethanoic acid CH3COOH reacting with
NaHCO3 give rise to CH3COONA sodium ethanoate plus water plus carbon dioxide gas. Here are two reactions. This carbon dioxide reaction turns lime water milky. Also, it shows efference. Efference is nothing, it's bubbles of gas, formation of bubbles of gas during a reaction. Let's discuss the in-text question. How do you distinguish experimentally between an alcohol and carboxylic acid? By adding NaOH. Sorry, not NaOH, it is NaHCO3. This is sodium hydrogen carbonates, because carboxylic shows reaction with it, whereas alcohol do not react with them. So you can easily distinguish between an alcohol and carboxylic acid. Next question is, what are oxidizing agents? These are those chemical substances which provide oxygen or remove hydrogen from a compound to complete oxidation reaction. The last topic of the chapter is soaps and detergents. Last but not least, soaps are long chain of sodium and potassium. These long chains of sodium and potassium has one loving part known as hydrophilic part and another long carbon chains which are hydrophobic. Hydrophobic hate water, hydroloving loves the water. So how this soap work on clothes? Yeah, on your faces. Clothes generally have oil stains. Clothes or our skin has oil impurities or oil stain. The hydrophilic part, loving part, has sodium ions, whereas the hydrophobic part has long carbon chains. Now this hydrophobic part get attached itself with the impurity, grease or dust, and slowly a lot of hydrophobic parts attach to the oil and pull it into the water. Now your cloth is free from stain and cleaning is done. But there is one problem with the soap. Soap do not soaps do not work in hard water. This is because hard water contains calcium and magnesium ions. They combine with soap and form white insoluble substance known as scum and reduces the lether. The solution to this problem is detergents. Detergents are nothing. Detergents are hydrocarbon chains of sulfonic acid and ammonium salts with chlorides and bromide ions. They do not form scum and can work equally in hard and soft waters. And act as good cleansing agent for shampoos, soaps and all, for cleaning clothes and all. Now next is in-text questions. Would you like to check if water is hard by using a detergent? No, because it does not form scum in any type of water. We can do so by the help of soap. If scum forms, it is hard water. If scum do not form, it is soft water. Next is, people use a variety of methods to wash clothes. Adding soap, beating clothes, peddling, brushing. This agitation, the use of this agitation, this physical agitation increases the contact of cleaning agent with the impurity, hence increases the clean clothes. That's all about this chapter. Carbon, a versatile compound, equally important for living things and non-living things, has a large number of compounds due to tetravalency and catenation, form covalent bonds, sharing of electron take place. It can form covalent bond with another carbon or hydrogen, oxygen, sulfur, has double and triple bond, also forms straight chains, branch chains and rings. uh, make it the ability of carbon to form long chains give rise to homologous series, which has same functional group and similar chemical properties but changing physical properties. Various functional groups like alcohol, aldehydes, ketones, carboxylic acid are present, which gives them different chemical properties. Carbon also act as a major source of fuel. Ethanol and ethanoic acid important in our day-to-day life. And last, action of soap and detergent, hydrophobic and hydrophilic group in the molecule, and the emulsification of oil and dust, causing it removal from the clothes and act as a good cleansing agent. That's all about the chapter carbon in its compound. Thank you. See you tomorrow with the next chapter, light. Thank you.